In this course, Valentin will teach you how to use GitLab CI to build CI/CD pipelines to build and deploy software to AWS.
Hello FreeCodeCampers, and welcome to this course which will introduce you to GitLab CI and DevOps. My name is Valentin, I'm a software developer, and I like to share my passion for technology with others in a way that is easy to understand. When I'm not speaking at a conference or traveling the world, I like to share what I know by being active in groups and forums and creating tutorials on YouTube or online courses. In this course, we will understand what GitLab CI is and why we need this tool, and start building CI/CD pipelines. During the course, we'll create a pipeline that takes a simple website, builds a container, tests it, and deploys it to the Amazon Web Services Cloud, also called AWS. In other words, we'll be focusing on automation. I've created this course for people new to DevOps who want to use GitLab to build, test, and deploy their software. Don't worry if none of this makes sense right now. If you're a beginner, that is totally fine. You don't need to install any tools or anything else. Also, no coding knowledge is required, but if you have some, it is great, it will help a bit. I will explain to you everything you need to know step by step. This course focuses on GitLab CI, but the course notes are packed with resources I recommend exploring if unfamiliar with a specific topic. Go right now to the video description and open the course notes. There you will find important resources and troubleshooting tips if something goes wrong. I will also be publishing there any corrections, additions, and modifications. Yes, this is a very dynamic industry and things change all the time. So if something is not working, first check the course notes. I am a big fan of learning by doing, and you will get hands-on experience building pipelines and deploying software to AWS. Throughout the course, I will give you assignments to practice what you have learned. While in this course, we'll be focusing on a specific technology and cloud provider, what you're actually learning are the concepts around DevOps. With the skills acquired in this course, I'm sure you'll be able to start using GitLab CI for whatever you need in no time at all. This is an action-packed course which I'm sure will keep you busy at least for a few days. As always here on FreeCodeCamp, please help us make such courses available to you by liking and subscribing. Also, don't forget to drop a comment below the video. If you like this course, I invite you to check out and subscribe to my YouTube channel, link in the video description, which is packed with content around DevOps, software development, and testing. Also, feel free to connect with me on social media. I would really love to hear from you. Finally, I would like to thank those who will support FreeCodeCamp by clicking that thanks button and making a small donation. I hope you're excited to learn more about GitLab CI, AWS, and DevOps. And with that being said, let's get started. I have designed this course to be as easy to follow along as possible. You don't need to install any software on your computer, and you should be able to do everything just from a browser. I'll be using GitLab.com throughout the course. If you don't have a GitLab.com account, please go ahead and create one. By default, you will get a free trial with your account, which will be downgraded to a free one after 30 days. It just takes a few steps to create an account. If you don't want to participate in the free trial, that's totally fine. There's also the possibility of skipping the trial altogether. GitLab is a platform that offers Git repositories where we store code and code pipelines which help us build software projects. Now that the registration process is completed, let's begin by creating our first project. And we're going to create a blank project. I'm going to call this project my first pipeline. I have the option of providing a project description, which is optional, and I can also decide on the project visibility, either private, which means that only I or people who I explicitly grant access to can view this project, or public, which means that it can be viewed by anyone without any authentication. I'm not going to initialize this project with a README file. I'm going to simply go ahead and click Create Project. This GitLab project allows us to store files and to use Git to keep track of changes and also to collaborate with others on this project. If the concepts around Git are not clear, check the course notes for a free course on getting started with Git for GitLab. Since for this account I haven't configured Git, you'll also get here this warning in regards to adding the SSH key. This is also covered in the material I have mentioned. But for the moment, we don't need this, so we can simply discard it. The first thing that I like to do is to change a few settings in regards to how this interface looks like. So from the user profile, I will go to Preferences. And here from the syntax highlighting theme, what I like to do is to select Monokai. So this is essentially a dark theme. And as you probably know, we like to use dark themes because light attracts bugs, and we definitely don't want any bugs. Now, leaving the joke aside, some people like it, some people don't like it. I prefer to use a dark theme when writing code, but totally agree that depends on everyone's preference on how to use this. There are also some other settings I want you to do right now in the beginning. So I'm going to scroll here a bit further down. And the first thing that I want you to enable is render whitespace characters in Web IDE. This will show us any whitespace characters when we're editing files. That's super important. Okay, we have everything that we need to do. So I'm going to go all the way to the bottom, click on Save Changes, and go back to GitLab. You'll see here your projects. So currently you have only one project. I'm going to click on it. And currently we have absolutely no code inside this project. The first thing that I want to do is to begin to create a file. So from this new GitLab project, we're going to use the Web IDE to create the pipeline definition file. I'm going to click here on New File. This will open up the GitLab IDE. So I'm going to create a new file. And we are already provided here with a template. And this file name must be called .gitlab-ci.yaml. If it's not exactly this name, if you're writing it on your own, this pipeline will not be recognized. So the pipeline file will not be recognized by GitLab. This is a very common mistake that beginners make. Probably this is why if you click directly on this one, you'll be pretty sure that you don't name this file like anything else. Now in this file, we're gonna define the pipelines and essentially gonna write here configuration to create pipelines in GitLab CI. It's totally fine if you don't know what that is right now. Just want to create a very simple example to make sure that we have everything we need in order to follow along with the rest of the course. So what I'm going to do here, I'm going to write something like test column, and then I'm going to go to the next line, and you will see here everything is already indented. So with this indentation, with these 4 spaces that you can see right now here, I'm going to write script, column, space, and then I'm going to use the echo command to display a text. So this is going to be the text that we want to display. The echo command is used to display a text, and we'll be able to see it later on. And this .gitlab-ci.yaml file allows us to describe our pipeline. As I said, don't worry if this does not make any sense right now. This is just a test to ensure we have everything we need to get started. So now what we're going to do is to actually commit these changes, which means introducing this file inside the GitLab repository. Now if you click again here on the project name, we'll exit this view. And you will see here that the pipeline failed. So every time we make changes to this project, the pipeline will be executed based on what we have defined in this YAML file. But you will see here right on top, there's this indication that something is wrong. And even here, if you look inside the pipeline, you will get this additional information. So what is going on? In order to run your pipeline using the GitLab.com infrastructure, you need to verify your account. Now, this is not the same as verifying your email address. You already did that, but you need to go an additional step of verification. Now, unfortunately, some people decided to take advantage of this free service and have abused it for mining cryptocurrency. For the time being, you will be asked to verify your account using a credit card. Now, your credit card will not be charged or stored by GitLab. and it is used solely for verifying your account, just to ensure that you are one of the good guys. And I know that you're one of the good guys, and I know that this is a bit annoying in the beginning, but this is how things are right now. I also know that credit cards are not that widespread in some countries, and this may be inconvenient. Maybe you can ask a friend to help out. I hope that GitLab will introduce alternative verification options. Nevertheless, verifying your GitLab.com account and using the GitLab.com infrastructure is the easiest way to follow along with the course. So if you can invest 5 minutes now and get this done, it will save you hours later. You can use your own infrastructure to run GitLab, but it is more complex. And from my experience of training thousands of students, is that people new to GitLab who use their own infrastructure have issues running their pipelines and waste a lot of time trying to get them to run properly. You have been warned, but if you want to go this path, I've added some resources to the course notes, which you can find in the video description. Now, in order to get started with the verification process, you have to click here on Validate Account. You will be asked to enter your credit card information. I hope that the validation has been okay. And in order to see if everything is working properly, we're going to go back to the project and open the web IDE. I'm going to click on the GitLab CI file to make a change to it. And I'm going to change here the message. So this is going to be now hello world 2. And I'm going to go here commit. So essentially making a new change to this file. I'm going to commit it directly into the main branch. And if I'm looking here at the bottom, I should be able to see that something is happening. So very soon a pipeline will be started. And you will see here now, pipeline with a specific number is running. I can click on it. And if you click here on this execution, you'll be able to see the job logs. And what we're interested in is firstly seeing this message here, hello world. And additionally, what we're also interested in seeing here is seeing this text here, which says pulling Docker image. Now, this is very important, not for this job itself, but what we are going to do throughout the course. So we want to make sure that whatever we have here in terms of the execution, that we are actually using Docker. If this is working, it's fantastic. You can jump directly into the next lecture. Otherwise, check the course notes for some troubleshooting ideas. So what is a pipeline? Allow me to make an analogy to an assembly line used to manufacture a physical product. Any product goes through a series of steps. Let's take a laptop, for example. To oversimplify, the assembly line would have the following steps. We'll take an empty laptop body case. We'll add the main board. We'll add a keyboard. We would do some quality assurance to ensure it turns on and works properly. Then we would put it in a box and finally ship it to customers. Now, we are not using GitLab to produce physical products. We want to build software. But producing software has similarities to what I have described before. Before we can ship anything, we go through a series of steps. Let's try to build the laptop assembly line in GitLab CI. Well, kind of. Instead of real components, we'll use a file, a folder, and some text. So let's begin with the first task. Take an empty laptop case. We'll put this in a job. In GitLab, a job is a set of commands we want to execute. So now let's go back to our project and make some changes to it. Again, I'm gonna open the web IDE to be able to view the pipeline file. Now, essentially, we already have a job here, but we're gonna expand this and make it build a laptop. If you're facing any issues getting the following steps to run, make sure to watch the next lesson where I'm going over some of the most common mistakes. Now, we already have a job, and this job is called test, but probably we should go ahead and rename this to maybe build a laptop, or we can also call it simply build laptop. Now in the script part, this is where we can essentially write commands. Now so far we have used this echo command, but the way we've written this allows us only to write one command. So what I'm going to do here, I'm going to go on the next line, and I'm going to start here with a dash, and this will allow us to essentially write multiple commands one after the other. So let's rename this in something like building a laptop, just to give us some information in regards to what we're trying to do. I want you to notice that after this dash, I have added a space, and you can see that space represented by a dot. Common mistake that people just getting started with GitLab, and this language that you see here, which is called YAML, is that they don't add the spaces or they don't properly indent what they see. So make sure that what you have inside your editor looks pretty much the same as what I have here. And if you're doing that, pretty sure this example will also work for you. Now, as I said, the language that we're using here to describe our pipeline is called YAML. And YAML is essentially a way to represent key value pairs. It may look a bit weird in the beginning, but after a few examples, I'm sure you will get used to it. Now, so far, our pipeline doesn't do anything. And inside this job, we actually said we want to build this laptop. And we also said that we're not going to use physical components. We're going to use folders, we're going to use files, we're going to use some text. So let's begin with the first command, which will create a new folder. Now, we want to put this into a folder which is called build. So on the next line, I'm going to use a command that will create a folder. This command is called makedir. And I'm going to call this folder build. So now we have a folder, and let's go to the next line and actually create a file. So I want my file to be inside this build folder. And in order to create this file, we're going to use the touch command. Now, the touch command is generally used for modifying the timestamp of a file. Essentially, you're touching it, you're modifying it. But it also has an interesting behavior which we will use here. If the file does not exist, it will create an empty file. And initially for us, that's perfectly fine. So we're going to create this file inside the build folder, which we created one step before. And with a /, we'll go inside this build folder. We can specify the file name, which in this case will be computer.txt. Now the next question is, how do we get some text inside this file? And in order to do that, we're going to use a command we have already used before. And this is the echo command. Now echo, if we don't do anything else like we did here, it will just print this message and we'll see it in our build logs. But we can also kind of redirect this and send it directly to a file. And for that, we're going to use an operator. So let me show you what I mean by that. I'm going to write here again echo. And the first thing that we are going to do is we're going to add here the main board. Now, let's say the file itself, it's just containing the laptop, and then we're adding components to it. So if you would keep this as it is right now, it will just display this information, it will just display main board. But we actually want to get it inside this file that you see here. So I'm simply gonna go ahead and copy it. And in order to get this text inside there, we're gonna use this operator. It's actually greater than. And essentially this operator takes the output from one command. So echo is one command, and it will append it to a specified file. So now we have specified here this computer.txt file, which is inside the build folder. So if you want to take a look and see exactly what is the contents of the file, we can do that as well. And for that, there are different commands that we can use. One option would be to use the cat command. And cat stands for concatenate, and can be used for creating, displaying, or modifying the contents of files. In this case, we're using this cat command to view the contents of a file. And again, we have to specify the path to that file. So just to make sure I don't make any mistakes, and always go ahead and copy paste the value of the file, the name of the file. And of course, we can also go ahead and add the other steps. So which other steps did we had? For example, we wanted to add a keyboard. So I'm going to add this again with a new command. And I think that should be it. So we have the main board, we have the keyboard. And of course, we can also try this cat command once again at the end. And this will give us an idea of how the job itself is working. In the previous execution, we haven't specified a Docker image to use. And by default, it will download a Ruby Docker image, which for our use case here doesn't really make a lot of sense. So we're going to use a very simple Docker image. It's a Linux distribution that will be started with our job. And we can do that by specifying here another keyword. And you will see here it's under the job itself, which is build laptop, but at the same level with the script. So I'm going to write here image, column, and the image name will be Alpine. So Alpine Linux is a very lightweight Linux distribution. What's most important for us is that this distribution has these commands that we're using. So these are pretty standard commands that are available essentially in any Linux distribution. But having a very small Linux distribution will make our job run much faster. So let's go ahead, commit these changes, and see how the pipeline runs. I'm going to commit again to the main branch. And if I'm impatient, I can click directly here on the pipeline. Or I can also go directly on the project page. And you will always see here the pipeline running. Pipeline is also available if you go here inside CI/CD pipelines. Will display you a list of all the pipelines that are running. You can click here on this one, which is the ID of the pipeline. You will see now our pipeline contains a job. And this job has been assigned to the stage test. By default, if no stage is defined, the job will use the test stage. Now, it doesn't really matter how the name of the stage has been called. We just want to make sure that the commands that we have executed are actually working properly. And we're getting here no errors, so the job is running. So the job has executed successfully. We can click on it, take a look at the execution logs, see exactly what has happened here. And you will see here in the logs the commands that we have executed. They're all visible here. You will see here echo building a laptop. You will see here the text being displayed. After that, we are creating a new folder. We're putting a file inside that folder. We're adding some text to that file. Then we're checking the contents of the file to make sure everything is fine. You will see here the word mainboard being displayed. And then we add the keyboard. And then again, you will see here the contents of the file containing both mainboard and keyboard. So what is a pipeline? It is a set of jobs organized in stages. Right now, we have a single job that belongs to the test stage. However, in the upcoming lectures, we'll be expanding this pipeline. It is quite common that when you're just getting started with defining these pipelines, that you make some mistakes. Let me show you some common mistakes that will lead to invalid configuration, which will lead to GitLab not running your pipeline. I'm going to make this a bit bigger on the screen so that you can easily check and compare it with what you have. It's very important that in some places you have this column. So for example, here I'm defining the job. And in order to add image and scripts as essentially properties of this job, it's important to have here this column. If I'm removing that, you will see here in the editor, when you see these lines here, it will indicate that something is wrong. Most of the time, these messages are really not so easy to understand. So it's more important to double check what you have written here to make sure it is exactly as it should be. It's also important that you have some spaces where there are spaces expected. So for example, here with the commands, whenever you're writing echo or make dir or touch, there needs to be a space between the dash and the command. This is why in the beginning I've asked you to enable these white spaces so that you can easily see them in your script. So if I write something like this again will make something weird. So it will not show here an error because this is actually valid YAML. But when GitLab will try to execute this pipeline and we'll look at these commands, we'll think that you're trying to run a command that starts with -echo, and we'll say, I cannot find this command. So for that reason, you need this space here to make a difference between this dash here, which indicates a list, and this command. What's also important is the indentation. As you can notice here, there are 4 spaces. So everything that is under build laptop is indented with a level. If I add something like this here, it will no longer belong to build laptop and will come out as something that's really weird, and most likely it will be invalid. So always make sure that you have the right indentation. 2 spaces are also fine. By default, this web IDE will use 4 spaces. Just make sure you have that indentation there in place. In the course notes, you will find even more examples of why your pipeline may be failing, including some common error codes that you may encounter. So definitely check the course notes if you're still having issues getting this pipeline to run. In this lesson, we'll try to understand what YAML is. If you already know YAML, feel free to skip this as I will not be covering any advanced features. The most important reason why you need to know some YAML basics is because you'll be facing many errors while writing YAML. And as I mentioned in the beginning, this is normal, trust me. I also did the same mistakes that you did. And sometimes I'm still making mistakes while writing YAML if I'm not paying attention. If you've already been exposed to formats such as JSON or XML, I'm sure you'll be able to understand the basics around YAML very easily. Actually, YAML is a superset of JSON, and you can easily convert JSON to YAML. Both XML, JSON, and YAML are human-readable data interchange formats. While JSON is very easy to generate and parse, typically YAML is considered easier to read. As you will see, not so easy to write, but we'll get to that. Quite often YAML is being used for storing configuration, and especially if you're learning DevOps, you probably face YAML a lot. And this is exactly why we're using it in GitLab as well to store a pipeline configuration. At its core, YAML follows key value storage principles. And let me open up here inside the editor a new file, and I'm going to start writing some YAML basics. So I'm going to create here a file. I'm going to call it test.yaml. And let's start with a few basics. So for example, how do we represent a key value pair? So for example, I have here a name. Typically would write something like the name is John, right? So this is something that anyone would understand. Now in YAML, we use a column to separate that. And so I'm going to add here name, column John. And what's also more important is that we have a space after this column. So it will be like this, and you will see here the color here will also change. So now we have a key value pair. The key is name and the value is John. We also call this a mapping. We're mapping a key with a value. Of course, on a new line, we can start adding an additional key value pair. For example, let's say here age 23. And what's important to know is that the order of the properties does not matter, so we can define them in any order. So if I write first name John and after that age, or the other way around, that's actually the same. Both are defined here in this YAML. Quite often we need to define lists, which in YAML are called sequences. And we do that by writing each value on a new line. So for example, let's write here some hobbies, call them sports, YouTube, and hiking, right? And what we also do is we put them, each of them on a new line, but each line must start with a dash and a space. So we have here a dash and a space, a dash and a space, a dash and a space. Now we have a list. Now, the way I've written this doesn't really work like that. So if we remove everything from here, this will be probably a valid list. But we cannot simply just combine these properties and now just add this list here in between. What's important to know about YAML is that it uses indentation for scope. Essentially, it allows you to know which value belongs to which key because it has the proper indentation. So for example, now we know this is not valid here, but if you write here, for example, hobbies as a key, then this list here will belong to this key. So essentially the mapping will contain a key and this list of values. While this is valid, we also like to indent this. So I'm going to select everything and click on Tab, and this will indent all these values here. Additionally, we can have some nested structures. So for example, if I'm trying to write here an address, so this will be the key. And then on a new line, I can write additional key value pairs, which all belong to the address. And you will see here I have the indentation, so I can write something like street. And on a new line, I can go ahead and write a city. And again, on a new line, I'm going to write here the zip code. And essentially, by using this indentation, we show that street, city, and zip, they all belong to address. If we didn't have this indentation, it would all be a property of something else. This is why in this case, we're using here name, age, hobbies, and address. These are like properties on the first level. And street, city, and zip, they are under address. In terms of lists, we can also build some more advanced lists. So this is a very simple list that we've used for hobbies. But let's say, for example, that we want to add here a new key, which is called experience. And here for the experience, we're going to create a list. And we just want to say like, what is the professional experience of this person? For example, we can have here a job title. That could be junior developer. And instead of creating here a new item in the list, we just go to the same level as with title. And then we can start writing something like period. So it will indicate in which period this person has been a junior developer, let's say from 2000 to 2005. And then we can go ahead and add a new item to the list. Again, with title, let's say now this person is a senior developer. And we're going to also define a different period. So this will be since 2005. Now, additionally, what we can do is we can take everything that we have here. And how about we define here, let's say this is a person, right? And then we can take everything that we have here and indent it once. And then all these properties that we have here will belong to a person. Now you can see here that we are still have some mistakes here. So we need to fix something because this editor will tell us this is a bad indentation. And as you learn, indentation is very, very important. So we're going to add here two spaces. I'm going to add here again two spaces. And now this indentation will be correct. Now, when we are writing GitLab CI pipelines, we don't really get to choose which data structures to use. We have the liberty of designing the pipeline, but we need to do it in a way that GitLab will understand it. So if we're looking here at our pipeline, we can just decide to use something else. So for example, instead of image, we cannot just decide we're going to call it Docker image or Docker. Or instead of scripts, we cannot write here scripts because this is something that GitLab will not understand. Yes, from a YAML perspective, this is still valid, but from the perspective of GitLab, this is something that's not according to what we agreed essentially in advance when we started writing these pipelines. So it's just important that you understand like what we're doing here and how this indentation and how this key value pairs are being written. But when we're writing jobs, we decide how this job will be named. We decide what exactly will happen inside it. Some keys will be reserved and simply cannot be renamed. You just have to pay attention that what you're writing here is really important and it has to be exactly, at least exactly as the examples that I'm showing you. Otherwise, GitLab will not be able to understand what you're saying. Throughout the course, we'll be using Linux and Linux commands. We have already learned some commands such as echo, touch, make dir, cat, and so on. We typically use these commands through a command line interface or CLI, what you see here. For example, I can go ahead and create here a new folder. I can switch inside that folder. We'll see here, for example, with ls, I will be able to list the contents of that folder. Let's go ahead and write here touch, this touch command, and create here file name computer. And again, with ls, I can see which files are inside the current folder. So we typically type these commands that you have seen in the pipeline through this command line interface or CLI. Sometimes we call it a console, a terminal, or a shell. While technically speaking, they are not the same thing, you may notice me and others use them interchangeably. A command line interface is the opposite of a graphical interface. This is a graphical interface. You will be able to see text, colors, you have buttons that you can click. Things are happening through your interaction. You're moving your mouse and you're clicking or something. You're using your keyboard and something changes on the screen. This is a command line interface. We will work with the command line interface to write commands. Computers we interact with have no user interface that we can use. Anyway, automating graphical user interfaces is not as easy and as reliable as simply using commands. The command line interface that computers have is called the shell. The shell is simply the outer layer of the system, the only thing that we can see from outside and interact with. So we send these commands to the system and the system will run them. This is how we can interact with it. When using GitLab CI, we essentially automate a set of commands which we execute in a particular order. While I will explain every command that we'll be using throughout the course, if this is something new, there's absolutely no replacement for trying things on your own. Please see the resources in the course notes for this lesson on setting up a Linux environment on your own computer and which Linux commands you should know. Let's talk for a minute about the GitLab architecture. At a minimum, the GitLab architecture for working with pipelines contains the GitLab server and at least one GitLab runner. The GitLab server manages the execution of the pipeline and its jobs and stores the results. The GitLab server knows what needs to be done, but does not do this itself. When a job needs to be executed, it will find a runner to run the job. A runner is a simple program that executes the job. A working GitLab setup must have at least one runner, but quite often there are more of them to help distribute the load. A runner will retrieve a set of instructions from the GitLab server, download and start the Docker image specified, get the files from the project Git repository, run all the commands specified in the job, and report back the result of the execution to the GitLab server. Once the job has finished, the Docker container will be destroyed. If Docker is something new to you, check the course notes for a quick introduction. What's important to know is that the Git repository of the project will not contain any of the files created during the job execution. Let's go back to our project. You will see here that inside the Git repository, there's no build folder, there's no computer.txt. So what exactly is happening? Let's go inside one of the jobs and quickly go through the log so that you can understand what is going on. So right here on top, you'll have information about the runner that is executing the job. And a runner will also have an executor. In this case, the executor is Docker machine. And here on line 4, you will see here which image is being downloaded. And you'll see here pulling Docker image Alpine, because this is what we have specified. And then essentially the environment is being prepared. And then in the upcoming steps, you get the files from the Git repository. So essentially all the files that you have inside the Git repository will also be available here inside the runner. So up to this point, the Docker container has been started, you have all the project files, and then you start executing the commands that you have specified inside the pipeline. So in this case, we're creating the folder, we're creating these files, we're putting some text inside there, and then at the end, we're not doing anything else. So the job succeeds because there are no errors, and the container is destroyed. So this Docker container that has been created in the beginning, just maybe a few seconds ago, is then destroyed. You cannot log into it, you cannot see it anymore, it doesn't exist anymore. So it has done its job, has executed these commands that we have specified, and then it has been destroyed. Since every job runs in a container, this allows for isolation and flexibility. By having our job configuration stored in the YAML file, we describe how the environment where the job is running should look like. In practice, we don't know or care which machine has actually executed the job. Also, this architecture ensures that we can add or remove runners as needed. While the GitLab server is a complex piece of software composed of multiple services, the GitLab runner has a relatively simple installation and can run on a dedicated server or even on your laptop. Now, right here on top of the job, you have seen some information in regards to the runner. So the question is, where is this job actually running? And to be able to understand this, we'll have to go here to the project settings, CI/CD, and here we're going to expand runners. And you'll see here two categories. There are specific runners, and there are shared runners. Now, for this job, we have used shared runners. Any project can use shared runners within a GitLab installation. These shared runners are offered by GitLab.com and are shared between all users. Now, as you've seen, there are multiple runners here, and honestly, we don't really care which of these runners picks up our job because we have defined exactly what our job should do, which Docker image we want to use, which command should be executed. So as long as that runner knows how to deal with a Docker image and was able to execute these commands, then we're fine with any runner. Now, this is an oversimplified version of the GitLab architecture. The main idea I want you to get from this is that we are using Docker containers in our jobs, and every time for every job, the GitLab runner will start a new Docker container, will execute any commands that we have, and then when the job execution is done, that Docker container will be destroyed. So now we have created this laptop and have defined all the steps inside the build laptop job. And of course, with this cat command, we have also visually verified that indeed this computer.txt file contains everything that we expect. But we really want to automate this process. We don't want to go inside the job itself and to look and see if everything was successful. So let's expand our pipeline and add a test job. We want to make sure that our laptop contains all components. So I'm going to go ahead here and create a new job. I'm going to call it test laptop. And we're going to use the same image, the Alpine Linux image. And we are going to also define the script. And this time we need to find a way to actually check, for example, if this file has indeed been created. So this would be like a very basic test. And what we can do here is to use the test command. So the test command will allow us to check if this file has been created. And this command also has a flag, which we're gonna write with -f, and then we'll specify the path to the file. So essentially, this command will ensure that this file really exists. And if it doesn't exist, it will fail the job. So let's go ahead, commit this, and see how the pipeline looks like. Now, if we're looking at the pipeline, we'll notice something unusual. And that is, we're building the laptop and at the same time we're testing it. And essentially what we wanted to do is to have this in two separate stages, right? We first build and then we test. Now, currently what we did is we assigned by default both of these jobs to the test stage. They both are running in parallel. But of course, these are not the kind of jobs that we can execute in parallel because they depend on one another. Particularly, the test job depends on first the build job completing. So I'm not even going to look at why the test build failed, because by the way this pipeline looks like, it doesn't make a lot of sense. And we have to go back to the concept of stages. So what we want to do is to have two different stages, and we're going to change our pipeline configuration and define these stages. We want to have a build stage and we want to have a test stage. In GitLab, we can go ahead and define another configuration, which is called stages. And here, as a list, we can define the stages that we want to have. So we can see here we want to have the build stage, and we want to have the test stage. And in order to specify which job belongs to which stage, in the job configuration, we will also say to which stage this job belongs. So for example, we want the build laptop job to belong to the build stage. So I'm going to write here stage, and the stage will be build. The same goes for the test laptop. Now, if we don't specify a stage here, it will automatically belong to the test stage by default. But actually, we want to make it as explicit as possible. So we're going to write here stage test. So here we have defined the stages. We have assigned the build laptop job to the build stage. And we have assigned the test laptop job to the test stage. So let's commit these changes and take a look again at the pipeline. Now, if we're looking at the pipeline, we'll be able to see now the two stages that we have, build and test. So these stages will run one after the other. This stage does not start until the build stage is over. So first we have to build a laptop and then we can start with a test. Unfortunately, this is still failing. So in this case, we really have to take a look inside this job and understand what is going on. And we'll see here that the last command that we have executed is this test command here. So up to this point, everything seems to be working fine. This has been the last command that we have executed, and somehow this job has failed. In the next lecture, we'll try to understand why do pipelines fail. So let's jump into that and continue debugging this problem. So let's try to understand why did this job fail. We're looking here inside the job logs. We'll be able to see here this error. It says job failed, exit code 1. Exit codes are a way to communicate if the execution of a program has been successful or not. An exit code 0 will indicate that the program has executed successfully. Any other exit code, which can be a number from 1 to 255, will indicate failure. So in this case, exit code 1 is not a 0, so it means something has failed. This exit code is issued by one of the commands that we have in our script. As soon as one of these commands will execute an exit code, the execution of the job will stop. In this case, we have only one command, so it's relatively easy to figure out which command has issued this exit code. Most likely, it is the last command that you see here inside the logs. So in this case, what test is trying us to tell is that it has tested for the existence of this file and couldn't find it. If the file would have been there, would have gotten an exit code 0, and the execution would have continued. In this case, the file is for some reason not there, and we have retrieved an exit code 1. This tells GitLab that this job has failed, and then the entire execution will stop. if a job in the pipeline fails, by default, the entire pipeline will be marked as failed as well. Let me show you an example. Let's go back to our pipeline definition. And we already know that the build laptop job works just fine. So let's say here, somewhere in the middle, we're going to add a new command. And this command will be the exit command. And we're going to exit with a code 1. So what we should observe is that commands echo, make clear, and touch are still being executed. But for example, here where we are putting the main board, we're using cat. And again, where we're putting the keyboard inside this file, this shouldn't be executed anymore. So now I've executed the pipeline again. You will see here that a build job failed. And because this job failed, the rest of the pipeline was not executed. So it was interrupted as soon as something has failed. It actually doesn't really make a lot of sense to continue with the rest of the stages if one of the jobs before has failed. So let's go inside it and take a look at the execution logs to see what exactly has happened here. And you'll be able to see, as I said, we have here this echo command that's being executed. We have created this directory, we have created this file, and then we have exit 1. And then it says here job failed, exit code 1. Now we have forced this failure here, but I just wanted to demonstrate like where in the execution you can notice that something went wrong. And actually going through these commands that are executed, looking at your job configuration, trying to figure out what has happened, what is the last command that did something. Sometimes inside the logs you will find hints in regards to what went wrong. In this case, there are not a lot of hints in terms of what went wrong, but these are also very simple commands. But it's very important to read the logs from the beginning as high as possible to understand like which Docker image has been used. What is happening before? Are there maybe any warnings or any hints that something went wrong? In this case, that's not the case. And then to locate, okay, what was the last command that I executed? Why did this command fail? So I'm going to remove this exit code and we're going to continue with the rest of the course and try to understand how we can get this simple pipeline to run. Let's go back to our pipeline configuration and understand what are we doing wrong. As you probably remember from the architecture discussion, every job runs independently, which means here the build laptop job will start the Docker container, will create this folder and this file, will put this text as instructed, and then at the end, will destroy the container, meaning the file that we had created inside this Docker container will be gone as well. And test laptop will start a completely new container that doesn't have this file there. And for that reason, it cannot pass. This test file will always tell us that there's no file there because from where could this file come? Now, does this mean that we can only use a single job, meaning that we need to move this command here to test inside the build laptop? Well, that would be very inconvenient because then we'd have a big job that does everything and would kind of lose the overview of what our pipeline steps really are. Now, there is a way to save the output of the job. In this case, the output of the job, what we are actually interested in this job, is this file, including this folder. And GitLab has this concept of artifacts. Now, an artifact is essentially a job output. It's something that's coming out of the job that we really want to save. It's not something that we want to throw away. For example, we may have used any other files or any other commands within the job, but we're only interested in the final output that we have here. So in order to tell GitLab, hey, I really want to keep this file and this folder, we need to define the artifacts. So the artifacts are an additional configuration, an additional keyword that we add to our pipeline. As the name tells, it's artifacts. Don't write it artifact because GitLab will not recognize that. And as a property of artifacts, we're going to use paths. So notice it is indented. It's not a list. And then below paths, we can add a folder or a file that we want to save. Now, in this case, we're going to tell GitLab, save everything that is inside this build folder. So now let's give it a run and see how the pipeline performs this time. Now, if we're looking at the pipeline execution, we now see that both building the laptop and testing the laptop are successful. So what exactly has happened behind the scenes? Did we reuse the same Docker container, or what has happened there? Well, to understand exactly what has happened and how these jobs now work, we have to go inside the logs and we'll try to understand what exactly did this build job do differently this time. And what I want you to notice here is that towards the end, if you compare it to the logs of the previous job, we also have this indication that something is happening. And it will tell you here, uploading artifacts for a successful job. And it will tell you here which artifacts are being uploaded. We'll reference here the build folder and says that 2 files and directories were found. And these are being uploaded to the coordinator. Now the coordinator, to put it very simply, is essentially the GitLab server. So in this case, the runner has finished this job, has noticed inside the configuration, oh, I need to do something with these files, and will essentially archive these files and will give them back to the GitLab server and tell them, hey, I'm finished with this job. I'm just going to destroy this Docker image. You wanted to keep these files, so here we go. Just handle these files. I'm done with my job here. So essentially, the runner is not saving these files. They're being saved somewhere else in the storage. Now, when the next job is being executed, something pretty similar is happening. I'm going to go here to the test laptop job. And what you'll see here in the beginning, there's also a new indication inside the logs that something different is happening. And we'll say here downloading artifacts. And it says again, downloading artifacts from coordinator, which essentially means we now are downloading this build folder inside the new Docker container that we have just created. So we have managed to copy these files from one job to the next one. And this is why now this test command is able to find the build folder and the computer.txt file inside it, and the job is passing. If this job is still failing for some reason, it's always a good idea to take a look at the job that has generated the artifacts. So in order to do that, again, we're going to go and visit the pipeline. And if we go inside the build laptop job, here on the right-hand side, you should see some information in regards to the job artifacts. And in order for these job artifacts to exist, they are saved even after the job has terminated. And you have the possibility of inspecting them. So if you're not really sure, like what is the contents of the file, you don't really need to go inside the build pipeline and make some debugging there. You could do that. But essentially, what has been saved here is the final version of the artifacts that are being used. So you can go here inside Browse. You'll find here the build folder that we have specified. And we'll find here the computer.txt. And of course, you can download this file and you can take a look at it after you download it on your own computer and see if it has the right content. Make sure that when you're testing this, you're actually giving the correct path and not some other path. That's a very important way on how you can actually inspect the outputs of the job. At this point, I wouldn't say that we are really done with testing the build output. Yes, this file exists and we have now tested it. So this is a very basic test that we have written here. But how about checking the contents of the file to see if it contains the mainboard and the keyboard as we expect? Again, just using a command like cat and displaying this in the logs doesn't really help us automate this. We need a tool that when it doesn't find the respective text in the file, it will issue an exit code and tell us that that text is not really present there. And for that purpose, we're going to use the grep command. So this is the grep command. And grep is a CLI tool that allows us to search for a specific string in a file. So we're going to specify here, for example, the string to be mainboard. And I'm going to copy it from above just to make sure I don't make any mistakes there. And we also can specify in which file we're looking for this. So we know that this file already exists. So this is an additional test here that we're adding on top of this. And now we know that the file exists, but now we want to check if this word mainboard is inside the file. And of course, we can also duplicate this and write an additional test here. We're going to check for the keyboard as well. So we're checking for the mainboard and the keyboard. Now, grep is a really complex command and can support regular expressions and many other advanced features, but I won't get into those. I'm going to commit these changes and in a few seconds, take a look at the pipeline. All right, so now if we're taking a look at the pipeline, we'll see the build job is still successful. The test job is still successful. So if we're looking inside here, what we'll be able to see, we'll be able to see some log outputs. And then grep here is looking for the word mainboard inside this file and is able to find it. It will be displayed here. It's also looking for the word keyboard inside this file and is able to find it. What's important about writing tests is to also ensure that your pipeline will fail if one of these tests doesn't work. And sometimes you may think that a command does what it's supposed to do, but the best way to make sure that you're really mastering that command is to actually introduce an error inside your build job, essentially, and to check if the test job will fail. So let's go ahead and try that out. So here inside our build job, what can we do? Well, for example, we could try and make a change here. For example, I'm going to remove the M from mainboard. And I'm going to simply commit these changes and to see if this job is now failing. So if I'm looking now inside the tests, we'll be able to see here that the last command that was executed was grep. You will see it in comparison to the previous one. There's no text being outputted below. This is the last command that was executed. We're getting an exit code 1, which essentially means grep has looked inside this file, couldn't find the word mainboard. So let's go back and fix our pipeline. But this has been a very important test, because if you're not really checking that our pipeline will fail at one point, then whatever we did inside the pipeline in terms of testing is really not very useful. So I'm going to go and add here mainboard back to the configuration. And as we expect, now the pipeline will also work again. Tests also play a very particular role when we're working on this pipeline, when we're building software. And there are many various levels of testing, but essentially tests allow us to make changes to our software or to our build process and to ensure that everything works the same. For example, I heard that if we are using this operator here and we're putting text inside a file, that this approach doesn't really require to have a file already created with the touch command. So how about we try this out and see if we can rely on the tests to get this to work. So I'm going to simply remove this touch command and I'm going to commit the configuration. We'll see what's going on. So let's take a look at the pipeline. And what do we see? This test job is successful. And if we really want to manually check once again, we can go to the build laptop job. We can take a look at the artifacts. We'll see the build folder is there. The computer.txt file is there. So apparently, we didn't need to have this touch command in our configuration. And by having the tests, we have gained an additional level of confidence that whatever changes we're making, we kind of trust the tests. And if the pipeline is passing, we know that in the end, we'll have this computer.txt file and we'll have the proper content. Let's take another look at our pipeline configuration. What if we need to change the name of the file? So far we have used this name, computer.txt. But what if we need to call it, for example, laptop.txt? Now, quite often, we don't really like when we have something, for example, a file name or something that could change and have that spread out through the entire pipeline, because if we need to make a change, we need to identify all occurrences. Now, this is a very simple example, and it is relatively easy to identify this. But quite often, for example, going into a large file and doing something like a replace all can lead to some undesirable errors that could occur. So quite often when we have something that we are essentially multiple times inside a file or inside the configuration, we want to put that into a variable. And that way, if it's inside a variable, if we need to make changes to that particular value, we only have to change it once, and then it would be replaced all over. So how do we define a variable? Well, we can go inside our script block and define a variable here. So for example, we can just define a variable called build file name. And we'll see I'm writing this in lowercase, and we have also some underscores to separate the words. And then we can use the equal sign and write something like laptop.txt. Now, in order to reference this variable, we're going to copy the name and go whenever we need to have this. And we're going to start with the $sign and then the variable name. So we're referencing the variable by using the $sign before the variable name. Now, this is a local variable that is available only inside this script, and it will only be available inside this job. So for this job, we need to do the same thing as well. As you've noticed, quite often we write local variables in lowercase, and using lowercase helps avoid any conflicts with any other existing variables. Now, this is one way how we can do this, but there's also the possibility of defining a variable block. So we can go inside the configuration of the job and write something like variables. This will not be a list, that's very important. So this will be build file name, column, and the value will be laptop.txt. So this is essentially almost the same as writing it like this, but we are getting it away from the script and we're letting GitLab do this for us. And of course, if we need to do this, we have to take it from here and also put this in the other job. So we'll have some duplication here in terms of the configuration. We can also define a global variable, which is available for all jobs. In order to define something globally, all we have to do is take it from here, and due to the indentation, we're going to move it outside of the job. And everything that's happening here is on a global level. So I'm going to move it here at the root of this document, essentially. Here we define variables, and this is the name. And whenever we have this, we have to use this syntax. And of course, we can go ahead and remove it from the test job because it would also be available there. Now, this is essentially as defining an environment variable, which is available for the entire system. While there is no hard rule, we typically write environment variables in all caps and still use underscores to separate the words. Because we are inside an IDE, I'm going to select this text, use the F1 command, and then I'm going to transform to uppercase. So this is how I want it to look like. Build file name. And wherever I want to have this, again, $sign and this name. So for example, I'm going to have it here for computer as well. Here in this command, which we may decide to replace or not, really depends on us, but I'm going to replace it here as well. I'm going to use it here, and here, and here. So again, wherever we had computer.txt, we have now replaced this with this environment variable. And whenever we need to make changes to it, we can easily just change it here. It's pretty easy to see. We may be adding some other variables that we have inside our pipelines. It will make the managing of these details much easier. While in this example, it is not necessary. Depending on which characters you include in your variable value, you may need to put everything between quotes. This is just something to keep in mind, but this is a very simple text here that we have. So that will not cause any conflicts in general with the YAML syntax. So let's commit these changes and see if the pipeline is still working as it should. The pipeline is running successfully, and we can go inside the build job that we had here, and we can take a look at the artifacts. And indeed, we'll see that now we are using this file name, laptop.txt, and no longer computer.txt. So I have mentioned DevOps quite a few times, and by now you have heard of DevOps as well. So what is DevOps? Let me tell you first what DevOps is not. DevOps is not a standard or a specification. Different organizations may have a different understanding of DevOps. DevOps is not a tool or a particular software, nor is it something you do if you use a particular tool or a set of tools. DevOps is a cultural thing. It represents a change in mindset. Let's take a look at the following example. You have a customer who wants a new feature. A business person, let's call them a project manager, would try to understand what the customer wants, write some specifications, and hand them over to the developers. The developers will build this feature, pass it on to the testers who would test it. Once ready, the project manager would review the work, and if all looks good, would ask the developers to pass the software package to the sysadmins to deploy it. As you can see, there's a lot of passing stuff around. And in the end, if something goes wrong, and often things go wrong in such situations, everyone is unhappy and everyone else is to blame. So why does it happen? Because every group has a different perspective on the work. There is no real collaboration and understanding between these groups. Let's zoom in on the relation between the developers and the sysadmins. The developers are responsible for building software, ensuring that all these cool features that the customers want make it into the product. The IT operations team is responsible for building and maintaining the IT infrastructure, ensuring the IT systems run smoothly, securely, and with as little downtime as possible. Do these groups have something in common? Yes, of course, the software, the product. The problem is the IT operation team knows very little about the software they need to operate, and the developers know very little about the infrastructure where the software is running. So DevOps is a set of practices that tries to address this problem. But to say that DevOps is just a combination of development and operation would be an understatement. Actually, everyone mentioned before works on the software, just in a different capacity. Since the final outcome impacts everyone, it makes sense for all these groups to collaborate. The cultural shift that DevOps brings is also tightly connected to the Agile movement. In an ever more complex environment, where business conditions and requirements change all the time, and where we need to juggle tons of tools and technologies every day, the best culture is not one of blaming and finger pointing, but one of experimentation and learning from past mistakes. So we want to have everyone collaborate instead of working in silos and stages. Instead of finger pointing, everyone takes responsibility for the final outcome. If the final product works and the customers or users of the product are happy, everyone wins. The customers, the project managers, the developers, the testers, the sysadmins, and anyone else I did not mention, everyone wins. However, DevOps is more than just culture. To succeed, organizations adopting DevOps also focus on automating their tasks. Manual and repetitive work is a productivity killer. And this is what we are going to address in this course: automatically building and deploying software, which falls under a practice called CI/CD. We want to automate as much as possible to save time and give us the chance to put that time to good use instead of manually repeating the same tasks over and over again. But to automate things, we need to get good at using the shell, working with CLI tools, reading documentation, writing scripts. Quite often, you may see DevOps being represented by this image. While this does not give a complete picture of what DevOps really is, it does show a series of steps a typical software product goes through, from planning all the way to operating and monitoring. The most important thing I want you to notice in this representation is that this process never stops. It goes on and on in an endless loop. This means that we continue going through these steps with each iteration or new version of the software. What is not represented here is the feedback that goes back into the product. DevOps goes hand in hand with the Agile movement. If Agile and Scrum are new to you, make sure to add this to your to-do list. Nowadays, many organizations go through an Agile transformation and value individuals who know what Agile and Scrum are, regardless of their role. I've added some resources you may want to look into in the course notes. If you have some free time while commuting or doing other things around your house, I highly recommend you listen to the Phoenix Project as an audiobook. It is an accurate description of what companies that are not adopting DevOps go on a day-to-day basis and realistically portrays such a transition. This is by no means a technical book, and I'm sure it will be a fun listen. So DevOps is a set of practices that helps us build successful products. To do that, we need a shift in thinking and new tools that support automation. However, I must warn you that you can use tools that have DevOps written all over them and still not do DevOps. So DevOps is so much more than just adopting a particular tool. With that being said, let's continue diving into GitLab CI. In this unit, we will start working on a simple project. We want to automate any of the manual steps required for integrating the changes of multiple developers and create a pipeline that will build and test the software we are creating. In other words, we will do continuous integration. Continuous integration is a practice and the first step when doing DevOps. Usually, we're not the only ones working on a project. And when we're doing continuous integration, we're integrating our code with the code other developers created. It means that every time we make changes to the code, that code is being tested and integrated with the work someone else did. It is called continuous integration because we integrate work continuously as it happens. We don't wait for anything to do that. We don't want to integrate work once per week or once per month, as it can already be too late or too costly to resolve some issues. The more we wait, the higher the chances we will run into integration issues. In this unit, we will use GitLab to verify any changes and integrate them in the project. I'm going to be honest with you. As we build more advanced pipelines, you will most likely encounter some issues. If you haven't done it yet, go right now to the video description and open the course notes. There you will find important resources and troubleshooting tips. Finally, let's do a quick recap. When we have multiple developers working against the same code repository, CI is a pipeline that allows us to add and integrate our changes even multiple times per day. What comes out is a new version of the product. If you're still unsure about continuous integration at this point, don't worry, we'll implement CI in our development process in the upcoming lessons. For the rest of the course, we'll be using this project. This is a simple website built with React, which is a JavaScript technology developed by Facebook. Now, we don't want to get too much into the technical details because they don't really matter so much at this point. But the first step in order to be able to make changes to this repository is to make a copy of it. So, for example, if you're trying here to open a web IDE in this project, I will get this option to fork the project. By the way, you will find a link to this project in the course notes, and the course notes are linked in the video description. So we can click here on fork and we'll make a copy of this project under our account. Now that we made a copy out of this project, we can then open the web IDE and start making changes to it. And particularly what we're trying to do is to create the pipeline. So let me give you an overview of the tasks that we are trying to automate. Essentially here in this project, we have a couple of files. one of these files is this package.json file. And this file essentially documents which requirements this project has. And in order to actually run this project, we first need to install these requirements. So locally, I already have a copy of this project, and the command to install these requirements is called yarn install. So now all the requirements have been installed. The next step would be to create a build, and that will be done using the command yarn build. And during this process, what has actually happened is that a build folder has been created, and this build folder contains multiple files that are required for the website. So let me give you an idea how this website looks like and what we actually did here. So I'm going to run the command serve -s, and I'm going to specify the build folder. And now, essentially, we have started a server. We started an HTTP server, which is serving the files available there. So I'm going to open this address in a new tab. And this is how the website looks like. So essentially, what we're trying to do in this section is to automate these steps. So we want to install the dependencies. We want to create a build. We want to test the build to see if the website is working. And I've shown you these tools because it is always a good idea to be familiar with the CLI tools that we will be using in GitLab CI. Now, in GitLab, we try to automate any manual steps. But before we do that, we must know and understand these steps. We cannot jump into automation before we understand what the commands that we want to do are actually doing. Now, I'm not really referring in particular to the commands that I've shown you here, because they are specific to this project. You may be using Python or Java or anything else. So you don't need to be familiar with these tools in particular. I will explain to you what they do and how they work. However, what is important to understand is the concepts. The concepts remain the same, and this is what we are actually focusing on in this course. We are focusing on understanding the concepts around automation. So let's begin creating the CI pipeline for this project. So I'm going to go ahead and create here a new file. And of course, the definition file for the pipeline will be .gitlab-ci.yaml. The first job that we want to add here is build website. And what we are trying to do here, where we're trying to build this website. And why do we need to build the website? Well, essentially, for most software projects do have a build step. In this case, we're essentially creating some production files, production-ready files, which are smaller, optimized for production from some source files. So we have here in the source files, you will see here an app.js and any other files. So essentially, the build process will take all these files and will make them smaller and will put them together in a way. Other programming languages may need to have a compilation step or any other step. So typically something happens in the build process where we actually are putting our project together. Now, of course, we don't want to do that manually from our computer. We want to let GitLab do this for us. So let's go ahead and write here the script for this. The first step is to essentially run yarn. And yarn is a tool that is helping us build this project. And this is specific for JavaScript projects, essentially Node.js projects, and yarn is a tool that can be used for getting dependencies. It can also be used for building the software. So the command that we are running here is build. Locally, as you remember, the first thing that I did was to do a yarn install to install dependencies. And this is something that needs to happen before the build. So every time when we are building this website, we need to get the dependencies to make sure that we have all the dependencies that we need and to ensure that all of them are up to date. And because they don't remain anywhere in the container, we need to do that all the time. Now, normally, locally, we would do that only when we need to do that. So for example, when we know that we need a newer dependency of a software package, but GitLab doesn't have this information. So we kind of like need to run this all the time. You also need to specify your Docker image. So let's try, for example, Alpine, which we have used before. So essentially what I'm trying to do is to replicate the commands that I've executed on my computer installing dependencies, and building the project. So let's commit these changes and see what the pipeline does. I'm going to commit them to the main branch and click on commit here. You can take a look at what the job is doing. And we'll be able to see here that we get an exit code. Now remember, any exit code that is not 0 will lead to a job failure. And it says here, job failed. Now, why did this job fail? Well, we have to look like what is the command that we try to execute. And we'll find here something saying that yarn not found. So essentially what this means is that the Docker image that we have used does not have yarn. So how do we install yarn, or how do we normally do this? Now the thing is, we don't have to use this Alpine image that you have seen here. Essentially for most projects, and this includes Node.js, which is actually what we're using here, and which I already have installed locally, and this is why it worked locally, there are official Docker images that we can use. And the central repository for such images is Docker Hub. So this is a public Docker repository. So for example, if I'm typing here Node, I will be able to find here the official image for Node. And I can essentially, instead of using Alpine, I can simply use here Node. So let me go back to the project. And I'm going to write here Node. Now the thing is, when we're doing here, when we're writing Alpine or Node, what is actually happening is that we are always getting the latest version of that Docker image. Sometimes it may work, but sometimes the latest version may contain some breaking changes, which may lead to things not working anymore in our pipeline. If one day we're getting one version and the next day we're getting something else without us making any changes, things may break. So for that reason, it is generally not a good idea to just use Node, for example, or just to use Alpine as we have done before. It is better to specify a version, to put it down like which version do we need here, and to write it down as essentially as a tag. Now, how do we know which version do we need? Now, for Node, what we're going to do here, we're going to head to nodejs.org. And here you'll see here 2 versions that are currently available for download. What we want to do is we want to use the LTS version. Now you will see here the latest LTS version that I'm currently seeing right now is 16.13.2. Now what's important here is the major version, which is 16. When you're watching this, it's important that you come to this page and you look at a number here. Probably it will increase over time. Most likely it will increase over time. You'll get a different version. It's important here that you get the latest LTS version that you see here. All right, so let's go inside our pipeline and then write this 16 version here. So the way we're going to do here, we have Node, which is the base image, and then we can specify a tag by writing column, and then I'm going to write 16, right? And most likely this version is already available on Node, but you can always make sure and check here, go to the tags and see if this specific tag is then available there. But these major tags, typically they are available and we'll have no issues downloading this. So let's commit the changes and see how it goes. And again, I'm going to push to the main branch. When this is executing, you will be able to see here which image is being downloaded. And you will see here it's Node, and the tag is for the version 16. Now this job is now requiring much longer to run. You will see here the duration in this case was 1 minute and 35 seconds. And this is because we have to download what is a relatively large Docker image, this Node image. And then we are installing the dependencies. And you'll see here that these dependencies take 44 seconds to be installed, to figure out which dependencies are required, to download them from the internet. That takes a bit. And then we are actually doing the build. And this also takes a few seconds to complete. But fortunately, everything is then successful in the end. And this is the most important step at this point. we don't want to waste a lot of time when we're actually executing these builds. And I know for a fact that this node image is a few hundred megabytes large in size. And this is because it contains a lot of tools and a lot of dependencies which we may not need. So for that reason, it's always a good idea for these larger images to go here on the specific image, to click here on the text tab, and generally to take a look at like what is the size of these images and what's happening with them, because some of them are quite big. So we could theoretically search here for version 16. And by default, we can see here that this is the one tag that's more specific. It's not exactly what we're using, but we'll see here version 16 something. It has about 332 megabytes. So if we're selecting to use this image, every time we'll have to download 300 something megabytes. So that's a lot of download and a lot of time that we're wasting just to start this image. So for that reason, what I typically do is I go here in the tags and I search for Alpine. Sometimes Slim or other images can also be a good idea. And what I'm interested in is something like 16 Alpine. So let me write directly 16 Alpine. And this looks absolutely fine here. So 16 will be, again, the node version that we are trying to use. And if we're looking here at the size, take a look at this. It's 38 megabytes. So what we're going to do, we're going to simply take this and go in our pipeline and replace 16 with this tag. So here inside, instead of using 16, we're going to use 16-Alpine. We're going to commit these changes. We're going to take a look again at the pipeline to see how long does it take right now to build this. So this job still needed quite a bit of time, 1 minute and 26 seconds. You may see this duration varying, but generally it is a very good practice to use images that are as small as possible because this can save time. And you may see that maybe this job will even go below 1 minute. It really depends like how fast the runner will pick up the job and will able to start this image. But the main idea is the same. We now have managed to automate the first steps in our project. We're installing some dependencies and then we are running the build. So this seems to be working just fine. Just to recap, we are using this node image. Before we have tried using Alpine image. Now, the Alpine image didn't work because it didn't have Node.js installed. Now, essentially what we're using here is essentially the same image as before, the same Alpine image, Alpine Linux image, but it has Node installed. So it has the dependency that we need. And this Node dependency contains Yarn. This is why Yarn didn't work before. Now it's working just fine and it's building the project. The most important thing that you can do when you're learning something new is practicing. And I want to give you the opportunity in this course to practice along. So not just following along what I'm doing, but to also have the opportunity to do something on your own. And for the next assignment, I really think that you have the know-how necessary in order to do that. What we're trying to do is to create 2 new additional jobs in this pipeline. And this is your job now to write these jobs. So what are these jobs all about? The first job is trying to test the website. And the website is currently inside the build folders. If I go inside the build folder, you will see here a list of files. Now your job is to ensure that the index.html file is available inside the build folder. So this is the first job that you need to create. The second job I want you to create is in regards to running unit tests. So in order to run unit tests, the command that we are using is yarn test. And the only thing you need to do is to create a job and to run this command to take a look at the logs and see that the tests have indeed been executed. The upcoming lesson will contain the solution to this, but please, it's super important that you pause this video and try this on your own. Try as much as you can, because this is the best way to learn and to ensure that what I'm showing you in this course is something that you will be able to use in your projects as well. I hope you have tried to solve this assignment on your own. But anyway, this is how I would approach this problem. So I'm here inside the editor for the pipeline. And let's begin just with the skeleton. So what are we trying to do? We have two new jobs. We have test website, where we're essentially trying to test the output of the build website job. And we also have a unit tests job. So first of all, we have to think about stages. What we want to do happens essentially after the build. Well, it really depends a bit. So for example, the test website, this definitely needs to happen after the build. The unit tests, they don't necessarily need to happen after the build, but we're going to put them inside a different stage as well. So let's go ahead and define the stages here. So we're going to have two stages. We're going to have here build, and we're going to have another stage, which is called test. And what we need to do is to assign these jobs to a stage. So the build will be assigned to the stage build, of course. And then the test website will be assigned to the stage test. And the same goes with the unit test, right? In order to test the website, what we are trying to do, well, let's try and write the script. We are trying to test if we have an index.html file there. So as you probably remember, the command test-f. So this we are testing for the existence of a file. This needs to be inside the build folder, and the name of the file is index.html. Now, what we haven't done so far is inside this build website job to declare artifacts. So as it is right now, this command will fail. So what we have to do here is, of course, think about the artifacts. So which artifacts do you have? We have to define the paths. And the only path that we're interested in is the build path. So then this will be able to test for this file. The next thing we need to think about is which image do we need for test website. So theoretically, we could use node 16, but actually this command test doesn't require something like that. So we could just use Alpine, and test is a pretty general command, so we don't have to worry about specifying a version or anything like that. So just going with Alpine should be just fine. In terms of the unit test, we essentially need this node image because we'll be using Yarn. So I'm going to simply go ahead and copy this image that we have used in the build website. And of course, the script will also be kind of a similar. We still need to install dependencies. So yarn install is necessary here when we're trying to run the unit test, and the command that we want to run is yarn test. So let's double check to make sure that we have everything in place. We have defined two stages, build and test. We have assigned build website to the stage build, and we have assigned the test website and the unit tests. We have assigned them both to the stage test. So this means these two jobs will run in parallel. Here, we're just using the test command to verify if this file exists. And here, we're installing the dependencies and then running the tests. So I'm going to go ahead, commit these changes, and we'll inspect together the pipeline. And after a minute or two, this pipeline will succeed. And you'll notice here the two stages, build and test. We're building a website and then we're testing what we have. The unit tests are not necessarily dependent on the build itself, but we put them together in a test. So if looking here at test website, what do we see? Well, we see here the command test -f. So it's testing if this file actually exists, if it's part of the job artifacts. Of course, if you're looking inside the build website, you can go here and look at the artifacts. See here the build folder. We'll see here multiple files. So not only the index.html file, but we'll see here some images, some additional files that we don't really care so much at this point, but they are available there. So that's the most important aspect that we really care about. And here the unit tests. The unit tests are part of the project. And generally, when we're writing code, we're also writing unit tests to document that what we're doing there is working properly. You will see here the command that has triggered the test has been yarn test. There's only one file here that contains only one test. All these tests have been executed. And because the tests are passing, the job is also succeeding. If any of these tests would not work, then the job will be failing and the entire pipeline will also be failing. The first tool we need for integrating work is already in place. We are using Git for versioning our code. We also use GitLab as a central Git repository. We take Git for granted nowadays, but it solves a critical issue and is one of the first DevOps tools you need to know. While this course does not go into Git, I highly recommend checking the course notes for a comprehensive Git tutorial. So in our current model, every developer pushes changes to the main branch. Whatever version of code has been pushed last time in the main branch, that is the latest version. Anyone wanting to add new changes will have to make them compatible with the main branch. However, this model does have a serious flaw. Nothing is safeguarding the main branch. What if the latest change has introduced an issue and we can't build the project anymore? Or what if the tests are failing? This is now a massive problem as nobody on the team can continue working and we can't deliver new versions of the software. A broken main branch is like when the production halts in a factory. It is not good for business. We must ensure that the main branch does not contain any broken code. The main branch should always work and allow us to deliver new versions of the software anytime we need to do that. So how do we solve this? The idea is simple. We just don't push untested work in the main branch. Since we can't trust that developers remember to run all tests locally before pushing a change, we want to take advantage of automation and GitLab to automatically run the tests before adding any changes to the main branch. The idea is to work with other branches which are later integrated into the main branch. This way, every developer can work independently of other developers. There are various Git workflows, but we will use one that is simple to understand. It is called the Git feature branch workflow. The idea is simple. For each new feature, bug, idea, experiment, or change we want to make, we create a new branch. We push our changes there, let the pipeline run on the branch, and if everything seems okay, we can integrate the changes in the main branch. So in other words, we simulate running the main branch before we actually run the main branch. If our branch pipeline fails, no worries. All other developers are unaffected and we can focus on fixing it. Or if we don't like how things turned out, we can just abandon the branch and delete it. No hard feelings there either. As part of working with branches, we create a merge request that allows other developers to review our code before it gets merged. A merge request is essentially one developer asking for their changes to be added to the main branch. The changes are reviewed, and if nobody has objections, we can merge them. So this is the plan for the upcoming lessons, to start working with Git branches and merge requests. So let's get to work. So how can we create merge requests in GitLab? First of all, to ensure that the chances of breaking the main branch are as small as possible, we need to tweak a few settings. So we're going to go here to Settings, General, and right here in the middle you should see Merge Requests. I'm going to expand that. And what I like to use when using merge requests is to use this fast forward merge. Essentially, no merge commits are created, and generally the history remains much cleaner. There's also the possibility of squashing commits directly from GitLab, and you can put it here on encourage. Squashing commits is when you're pushing multiple changes to a branch, Instead of pushing all these changes back into the main branch, we squash them all together. So we essentially, like, we have only one commit. Again, makes the history much easier to read. Going forward, here in the merge checks, we want to make sure that the pipelines succeed before we are merging something. So this is a super important setting here that we have. So let's go ahead here, go at the bottom and click on Save Changes. And additionally, again, from settings, we're going to go here to repository. And from the repository, we're going to go here to protected branches. I'm going to expand this. And what we want to do here is we want to protect the main branch. So essentially, we don't want to commit changes to the main branch anymore. We want to prohibit that. So nobody will be allowed to directly commit something to the main branch. So in order to do that, we have to go here to allow to push. And instead of having something selected or some role selected here, I'm gonna use no one. So no one is allowed to push to this protected branch only if it goes through a merge request. So these are the initial settings that we need to do. And we'll be able to see here now. Let's try and make some changes and open the web IDE. Open the pipeline file. And now let's say I'm trying to add here a new stage where I'm trying to do some checks. For example, there is a linter that I can use. And a linter is simply a static code analysis tool that is used to identify potential programming errors, stylistic issues, and sometimes, questionable code constructs. Since it is static, it does not actually run the application. It just looks at the source code. And most projects do tend to have such linter inside. And just for the sake of completion, I also want to add here linter. So I'm going to go ahead here and I'm going to write here linter. This is the name of the job. The image that I'm using is still Node here. And the reason for that is inside the script, the command that we are running is actually yarn lint. And of course, we also need to install all dependencies. And additionally, we have the possibility of assigning this job to a stage. Now, by default, GitLab comes with some predefined stages. Predefined stages include a press stage, build stage, a test stage, a deploy stage, and a post stage. So these are all actually predefined. And to be honest, this is just to make it clear like which stages we are defining here and which stages we are using. But these are already defined by GitLab, so we're just essentially redefining something that exists. So for this linter, I could go ahead and use a stage, and this stage name will be .pre. And this linter has absolutely no dependencies on the build itself. The same goes, for example, here with the unit tests. The unit tests are also not dependent on the build, so I could go ahead and move them to the same stage. Oops, just to make this clear. So there's a dot there, and because this is a predefined stage, we don't need to redefine it again. So I could go ahead and write it here, but it's not really needed, all right? Now going back here, the editor that I opened here is from the main branch. You will see here main is selected, right? And let's go ahead and commit. And you will see here, I'm no longer allowed to commit to the main branch. So this is by default disabled. The settings that we did ensure that we are no longer allowed to directly make changes to the main branch. So we have to create a new branch. Quite often, when we're creating branches, we tend to use some naming conventions. Now, totally up to you what you want to use or how your organization uses that. Quite often, you'll have something like feature, for example, / and then a name of a feature. Sometimes you may reference a ticket or something like that. So for example, you have here a ticket number, 1234, add linter. So you will see here I'm adding no spaces or anything like that. It's totally up to you how you use these / hyphens as separators and so on. You'll also see here the possibility of starting a new merge request. So I'm essentially these changes now are not committed. I'm going to create a new branch. The branch name will be feature / and some name. I'm going to click here on commit. This will open an additional window. So the branch has been created, but now I'm also opening a new merge request. And here in the merge request, there are a few things that I should fill out. So for example, the title is not very suggestive. So I'm going to write here something like add linter to the project. You can also go ahead and provide a description. This is also useful for the people who are looking at this merge request to know why this is important, what this feature is bringing, or if it is a bug fix, which issues is this fixing, and so on. So you could do that. But there are also some additional labels and options that you can set here. I'm not going to go over them because they are essentially relatively easy to explain. And I'm going to go here and click on Create Merge Request. And now a new merge request has been created. And additionally, we also have here a pipeline that is running against this branch. So what is happening here is that the changes that we made, which you will be able to see here, what we do, we added here a new stage, we added here a linter, also made some changes to the unit test, so we can go ahead and look at these changes. We have here a pipeline that's executing. It's going through all these stages. We have here the pre-stage, the build stage, and the test stage. And now we can simulate running this pipeline to see if it fails. If it fails, we have the opportunity of fixing things. If it doesn't fail, then we have the option of merging these changes. The next important step in the life of a merge request is the review process, especially the code review, where somebody else from the team is taking a look at our changes and is giving us feedback. Now, just in case you don't know where your merge request is, you will find here on the left-hand side, this panel says here merge requests, and will indicate how many merge requests are open at this time. So we only have one merge request. You will see here, this is the title of the merge request. So we're trying to add linter. And you'll find here like the most important information. So this is a request to merge this feature into the main branch, right? If you need to make changes to it, you can open this branch in the IDE and continue making changes to it. You have here information about the pipeline. So we know that the pipeline has passed. And someone else looking at this will be able to see here which commits have been made and also to have an overview of the changes. Inside here, there are different views that you can have. You can compare these files, and someone can also leave comments here. So for example, I could simply click here on a line and ask, why did you use the pre-stage, right? And can add a comment. Now, where does this merge request go? Now, typically, when someone has reviewed this, can go ahead here and approve it. So you will see here who has reviewed these changes, and you may have internal rules like you need two people to review any changes before they are being merged. So the changes can be approved and then they can be merged. Comments can appear. So for example, here I've added a question to these changes. So maybe there's some discussion that needs to happen there. Feedback can be gathered from different people involved. And this feedback may need to be integrated. So for example, as I mentioned, you can still do changes to this. The merge request will always have the latest changes, so we can make more commits. It's also possible that for some reason, these changes are no longer needed. They are wrong, or the approach that was taken doesn't really make sense. So there's also the possibility of closing a merge request. You can go here and see close merge request. So this will be closed and no changes will be merged. So that's also a possibility. But typically what happens after the review, after some changes have been integrated, we're going to go here on this merge button. And what is happening here is we are merging this branch into the main branch. And there are two options that are enabled by default. The source branch, so the branch that we have created, will be deleted, which makes sense because we don't need it anymore. And in case we have multiple commits, we can also squash those commits. And in this case, we have only one commit. We can modify the commit message if we want to. In this case, that's not needed. And then we can simply click here on the merge button. This merge button is available only if the pipeline succeeded, but our pipeline did succeed, so this is why we can see it. So now GitLab will merge these changes into the main branch. And again, a new pipeline will be generated. And this is the pipeline for the main branch. So you will see exactly the changes that we made. We have here the pre-stage, the build, and the test. These are all available here. And exactly what we have run inside a merge request, the pipeline is running again against the main branch. And this is needed just to ensure that indeed everything is working fine and that there are no integration issues or no other issues. So it's a good practice, not something that may seem that it's happening somehow as a duplicate. It's actually important to ensure that the main pipeline is working properly. This is what we care most about, to ensure that this main pipeline is working as it should work. That's the reason why we have reviewed the merge request, to ensure that whatever we're changing here in the main branch is as good as it gets, and that the chances of breaking something are drastically reduced. Right in the beginning of this section, I showed you locally which are the steps needed to build this project. But I've also taken the build folder and I've opened the website, and you have seen something that looks like this. How can we replicate this in GitLab? Essentially, we want to make sure that we indeed have a website that's running, that can be started by a server. And we want to make sure that, for example, this text here shows up, learn GitLab CI. How can we do that inside the pipeline? Currently, we're just checking if we have a file which is called index.html. That's not really telling us the entire story. So in this lecture, we're going to take a look at how we can do essentially what's sometimes called an integration test. We're really testing that the final product is really working. I'm going to open up the web IDE, and inside the pipeline file, I'm going to focus on this test website job. So this current test is not really that helpful. We want to do something else. So for example, you have seen me running the following command, which has been serve -s build, right? So this takes the build and we'll be able to start a server, and then we can take a look at what's going on. So we're going to remove this because we don't need that anymore. I'm going to start here a server. And just because I want to make sure that this is running as fast as possible and that we're not wasting a lot of time, I'm going to go ahead and disable some jobs. So I'm going to disable here the linter job. That's not really needed in the beginning. I'm going to also disable the unit test. So to disable the job, you simply add a dot in front of the job name, and that job will be disabled. Let's go ahead and commit these changes. And again, we'll have to create a new branch. Call this feature integration test. I'm going to start a new merge request as well. I'm going to call it add integration tests. I'm going to click here on create merge request. Now, if we're looking at the pipeline, we'll see that the build has succeeded, but there seems to be an issue with testing the website. So let's take a look at the logs and understand what is going on. We'll try to understand here what is the error. We're getting an exit code. The last command that we executed is serve. And we're getting here serve not found. So again, we're trying to run a command. This command was working locally for me, but at least the Docker image that we are using here does not have this command. So which Docker image are we using? We're using Alpine, and Alpine does not have this command. So we need to find a way to install this command as well. So for that, we're going to go back to the editor. We can go here from the merge requests, click on the merge request, and we'll find here open in Web IDE. And then we'll be able to see here. This is essentially a list of changes that we have. This is the review. It shows us what we have changed. But if you want to make changes to the code, we're going to go here. So this will allow us again to select the pipeline file and make changes to it. So let's see what we need to do in order to get this job to run as well. Now, first of all, we're going to use here this same node image, because serve is actually something that runs on node. So it's a dependency that runs on node. And we're going to use yarn, and we're going to add this dependency. I'm going to see here, yarn add serve. And actually, you're going to use this as a global dependency. So I'm going to write here global. So using yarn global add serve, right? So this will ensure that we now have serve. We can use yarn because we now have the node image. Again, this time we are already in a merge request. So we can go ahead, click on commit. I'm going to commit directly here to the existing branch that we have. And the pipeline will be executed again. Be sure to watch what I'm explaining next, because we have introduced an issue in this pipeline. And it's a big issue, but I'm going to explain in a second what that issue is. So I'm going to go ahead, open this pipeline, and I'm going to go directly to this test job. And I'm going to wait a bit here to see what is happening. I'm going to wait for this job to start. So I want you to notice what is happening with this job. So we have started this Docker container, which contains node. Then we have added this dependency, which is serve. And then we have executed serve. Which folder are we serving? We're serving the build folder. Then it says here, info accepting connections on localhost port 3000. So what is going on? Well, we have started an HTTP server, which is serving these files inside this GitLab job. And when does a server end? Well, it never ends. That's the purpose of the server. It will serve these files indefinitely. And of course, this approach that we started here is not good, because we're gonna wait here forever. Well, actually not forever. Jobs do have a specific timeout. You will see here the timeout that is 1 hour. So if we don't stop this job will run for 1 hour. So this is an important concept. When you're starting a server inside a job, that job will never end or will run into this timeout. So be very careful when you're doing things like that. Now I'm going to go ahead and manually stop this job. You will see here this cancel button here. We cannot wait forever, so I'm going to cancel it. And then this will stop. Now, there is a way to start a server, and there is a way to check that text, but we still need to make some changes. So I'm going to go back again to the pipeline. Let's go inside the code, open the pipeline, and see what we have here. Now, what do we want to do? So we have managed to start this server. It will run forever, but how do we test something? So in order to test something, we have to execute the upcoming command. And in order to actually get this information, we need what's essentially an HTTP client. We need another tool that will go to this address, which is, you have seen there, it's starting on localhost, which is the host name on port 3000. And the protocol is HTTP. So we don't have a browser that we can open here. So we need something that is as close as possible to a browser. So that tool is curl. So curl is a tool that will be able to go to this address, download the website, and then we can do something. I'm going to use here a pipe. So this will send the output of this website to the next tool. And as you remember from working with files, we have the possibility of using grep. So grep will search for a specific string. So what is the string that we're looking for? I think the string is learn GitLab CI. I'm going to check again against the website to make sure that I have this exact text here, because this is what we are trying to find inside the website, right? So we're starting a server, then we have this curl command, and in grep we're getting the website, and then we can search for this string. We still haven't solved the problem with the server running forever. We don't want it to run forever. So we're going to use a small trick. I'm going to use here this and sign. And what will this do is to start this process in the background. So it will essentially still start this server, but it will be in the background and it will not prevent this job from stopping. So when the curl command has been executed, this job will also stop. Because this command will be executed right after this one, curl will not wait for the server to actually start. The server needs a few seconds to start. And in order to wait for that, we don't know exactly when this will start. So we're going to use another command, which is called sleep. And sleep will take a parameter here. So this will be in seconds. So we can decide how many seconds we want to wait. Just to be sure, I'm going to use here 10 seconds. Additionally, curl is also another command which we don't have. And this is actually a dependency of this Alpine image. So this has nothing to do with yarn or npm as serve does. This is an exception. So for that reason, we have to use here the package manager from Alpine. So APK, this is the Alpine package manager. And we're going to add here curl. So this is how we are adding curl as a dependency. So let's give it another try and see if this works. Now, if we're looking at the logs, we'll see that this is still failing. Maybe this is not our day, but let's go through the process again and try to understand what is going on. And generally, I have to tell you, we have to get used with errors. And the more we understand about these, the more we are able to solve this kind of problem. So we have added serve, we have added curl, and we started the server. We can see here if we're still getting this information, accepting connections at. We waited here for 10 seconds. Curl has downloaded this and then has sent this to grep. But we are getting here an exit code 1. Because we're not seeing any errors from curl, which means that curl has downloaded this information, we have to wonder like what's going on with grep. Why isn't this information available there in the response? Now we could go and debug this a bit more. But essentially, when curl is downloading a website, it's not really downloading what you see right now here. It's actually, if you click on this, go here to view page source on any website, what curl is actually doing is downloading this. Now, this is the index.html file, and this index.html file will download other things in the background, will download some scripts. So that information there is not really coming from the page, from this page that we are getting with curl. And curl doesn't have the possibility of actually rendering JavaScript and images and so on. So it's a very basic tool. What we have here, for example, is this React app in the title. So how about if we change this and we're asserting that we have this title? So let's go ahead in the application and figure out where this React app appears. I'm going to change it to something with GitLab. So instead of using learn GitLab, we're going to simply try and use React app because we know this is available here. So from the project, I'm going to open the web IDE. If I'm not in the right branch, I can simply switch the branch, open the file that I want to edit. So we're going to use, instead of learn GitLab CI, I'm going to use here React app. And we are also going to enable the rest of the jobs, which are the unit tests, which have been disabled. The linter has been disabled. And then we're going to put all these changes together, commit them to the branch. We're not going to start here a new merge request. We already have a merge request. So we're going to disable that if it's enabled. I'm going to commit again. And finally, the tests are working. So let's go again and inspect the job logs. So what we find here, well, we have everything that we are interested in. And particularly the last part was the one that was failing. And now it's able to locate this inside here. So this is why you're getting back the entire text. You will see here React app. It's in the response. So curl and grep now work together and this job succeeds. It has been a bit of work, but I'm happy that we have this test and it ensures that our pipeline really works a bit better and that we're more confident in what we're building. I'm going to go here to the merge request. You will see here we have 4 commits. And we have here essentially the changes that we made. So we reverted all the other jobs that we have disabled, and we just have adapted this test website. So from that point of view, everything is good. We're going to squash here the commits, so we can also modify the commit message. Commit message is add integration test, so that looks good. I'm going to click here on merge, and these changes will be merged into the main branch. So currently our continuous integration pipeline looks like this. It is divided in 3 separate stages. And the way I've structured this is just an example. There is no hard rule. Different programming languages and technologies may require a different order. You are smart people, and I'm sure you'll be able to apply these ideas to whatever you're doing. However, I just wanted to mention 2 principles or guidelines that you should consider. One of the most important aspects is failing fast. For example, we want to ensure that the most common reasons why a pipeline would fail are detected early. For example here, linting and unit tests. Quite often developers forget to check their linting, make a mistake, or forget to run the unit test. So if we notice that this is happening a lot, it really makes sense to put this as the first stage of the pipeline. They typically don't need a lot of time, so the faster they fail, the better it is, because we'll get fast feedback, we'll use less resources, and of course, if we're running here in parallel jobs that are similar in size, that's also a relatively good way of grouping jobs together. Now, you also have to be very careful when you're grouping jobs in parallel. For example, if you have a job that finishes in 15 seconds and you have a job that finishes in 5 minutes, for example, let's say here linter needs 15 seconds, unit test needs 5 minutes. If the linter fails after just 5 seconds, the unit test will still run for 5 minutes. There's no stopping there. So it does make sense to put in parallel jobs that are similar in size. Another aspect that you need to consider are the dependencies between the jobs. So what do I mean by dependencies? Well, for example here, we cannot test the website until we have actually built the website. But the linter and the unit tests, they don't depend on the build output. So for that reason, we can run them before the build, we can run them after the build. We don't have a dependency there. But in this case, for the website, we are dependent on the job artifacts because we're using them for something. So from that perspective, we always need to have the build job before here we can test the website. So if jobs have dependencies between them, they need to be in different stages. Now I have to say that there is no replacement for experimentation and trying things on your own. If you're unsure if something works or not, just give it a try and see how far you can go and why that pipeline fails. As you have noticed so far, our pipeline does require a bit of time. And actually optimizing these pipelines is a lot of work. So what I wanted to show you is just a very simple way on how we're going to save a bit of time throughout this course so that we don't wait so much for each of these stages. So again, I'm going to open here the web IDE. And what I want to do is to essentially restructure these jobs. Now, as you can notice here, the build website, the linter, and the unit tests, they are all pretty similar. They all use the same image. They all need to install yarn dependencies, and they just run a command after this. So one idea would be to, for example, take the linter, so yarn lint, and to put it right here after we have installed the dependencies. And in that case, we don't need this job anymore. Same goes for the unit tests, right? We're gonna take here the unit tests and put them after yarn lint. And again, we're not gonna need this anymore. Also not gonna need the stage. We can reduce this to just 2 jobs. So this job indeed has this image, which is the same as this one, but doesn't have any dependencies. So it's just installing surf here, it's installing curl. So I don't want to really combine this in a single job. We could theoretically put everything in a single job, but I'm just doing it now for performance purposes. And in order to save a bit of time, we're just gonna stick to these 2 different stages, the build stage and the test stage. And even if you're doing here a bit of testing, it's acceptable now to be able to save a bit of time. And as I said, it's totally up to you how you structure your pipeline. But this is why we are removing now this. I just wanted to show you how they look like. But for the rest of the course, we don't want to waste so much time waiting for these stages to complete. So for that reason, this will be a bit easier. I'm going to create a merge request and merge these changes into the main branch. If you're binge watching this course, make sure to take a break after a few lessons. There is a lot to take in, but you need to take care of your body as well. So get up from time to time, drink some water, eat, or go outside and relax your mind. And trust me, taking a break is so much more productive than staying all day in front of your computer. If your body does not feel well, this impacts your productivity and energy levels. So I'm going to take a break as well, and I'll see you in a bit. In this unit, we'll learn about deployments, and we'll take our website project and deploy it in the AWS cloud. Along the way, we'll learn about other DevOps practices such as continuous delivery and continuous deployment. By the end of this section, we'll have a complete CI/CD pipeline that will take our website, build it, test it, and let it float in the cloud. Just a quick reminder, in case you get stuck or something does not work, check the video description for the course notes, which include troubleshooting tips. If this sounds exciting, let's begin. Amazon Web Services, or simply AWS, is a cloud platform provider offering over 200 products and services available in data centers all over the world. AWS offers a pay-as-you-go model for renting cloud infrastructure, mostly for computation or data storage. So instead of buying physical hardware and managing it in a data center, you can use a cloud provider like AWS. Such services include virtual servers, managed databases, file storage, content delivery, and many others. AWS started in the early 2000s, and its adoption continued to increase over time. Maybe you have heard the story when the New York Times wanted to make over 1 million old articles available to the public. A software architect at New York Times has converted the original article scans into PDFs in less than 24 hours at a fraction of the cost a more traditional approach would have required. And this was back in 2007. Today, many organizations can't even imagine their IT infrastructure without using some cloud components. While this course focuses on AWS, the principles presented here apply to any other providers. If you don't already have an AWS account, don't worry, it's quite easy to create one. Enter your personal details and click on Continue. Since we're using AWS for learning and experimenting with it, I recommend choosing a personal account. AWS is a paid service, and even though in the beginning there is a free tier that has some generous limits and is ideal for learning and experimenting, you are still required to provide a credit card or debit card for the eventuality you will go over the free limit. I would go with a free basic support plan, which is fine for individuals. Now that we have an AWS account that is verified and has a payment, What we need to do next is sign in into the console, because from the AWS console we can access all services that AWS offers. If you're seeing the AWS Management Console, it means that you have set up everything correctly, and you can continue with the rest of the course and essentially start using AWS right away. Let's do a bit of orientation. This is the main page from where you navigate to all AWS services. AWS services are distributed in multiple data centers, and you have the possibility of selecting the data center you would like to use right here on the right side on the top of the menu. I will go with US East 1, North Virginia. You can use whichever region you like, just remember the one you have selected, as this will be relevant later on. Typically, the data centers in the US have a lower cost than others that are spread around the globe. And right here you have a list of all services available. You can also search for services in this search bar. Finally, I highly recommend that you go to your account profile and enable multi-factor authentication. This will significantly raise the security of your account. That's about it. Now you can start using AWS. The first service that we want to interact with is AWS S3, which stands for Simple Storage Service. You can find the service by simply searching for it. You'll see here S3. I'm gonna click on it. And there you go. This is AWS S3. S3 is like Dropbox, but much better suited for DevOps. Actually, for a long while, Dropbox was using AWS S3 behind the scenes for storing files. But let's go back to the course. Since our website is static and requires no computing power or a database, we will use AWS S3 to store the public files and serve them to the world from there over HTTP. On AWS S3, files, which AWS calls objects, are stored in buckets, which are like some super container folder. Now you may notice that your AWS interface looks a bit different than mine. AWS is constantly improving the UI and things may change in time. However, the principles that I'm showing here will stay the same. So let's go ahead and create our first bucket. First of all, we have to give our bucket a name. And the name of the bucket needs to be unique. So I'm going to give this bucket a unique name so that I don't run into conflicts with anyone else who may have created a bucket with the same name. So I'm going to just give here my name and a dash, and after that I will give here a date. Additionally, you'll have here the AWS region, and in my case, I'm going to keep it exactly as it is. Then there are also a bunch of settings that we'll not look into right now. So right here at the end, I'm going to click here on Create Bucket. All right, so the bucket has been successfully created. And we can go inside the bucket and to see if there's anything in there. But at this point, there are absolutely no files. Of course, we could go ahead and manually upload files or download files or things like that. So through the web interface, it's possible to add files and folders. But this is not what we are trying to accomplish with DevOps. We want to automate this process. So for that reason, I'm going to leave it as it is. And in the upcoming lectures, we're going to find a way on how to interact with AWS S3 from GitLab. So how can we interact with the AWS cloud, and particularly with AWS S3 in order to upload our website? If you remember in the beginning, we talked about how we typically interact with computers, and that is through a CLI, command line interface. So for the AWS cloud, we need a command line interface to be able to upload files, for example. And fortunately, AWS has already thought about that. And there is an official AWS command line interface that we can use. There's also here a very in-depth documentation about the different services that are available. And throughout the course, we're going to also navigate through this documentation. because I want you to understand the process of interacting with such services and the importance of actually using a documentation and not just replicating what I'm doing on the screen. Now, to be able to use the AWS CLI inside our GitLab pipeline, we need to find a Docker image, and the best place to search for Docker images is in Docker Hub. So here inside Docker Hub, I'm going to go ahead and write AWS CLI. And I'm going to find here, we'll see it, it's under verified content. If possible, we always try to use verified official Docker images. I'm going to take this one. So all I have to do is simply copy this, and then we're going to go inside our pipeline. Open the web IDE again. And let's go ahead and create a completely new job here. So I'm going to call this job deploy to S3. And we're going to add an additional stage here because we need to do this deployment after the CI pipeline is done. So we have tested everything. And after that, if everything passes, then we're going to move to the next stage, which is the deploy stage. So I'm going to write here stage deploy. And the image that we want to use is the one that I've just copied, which is Amazon/AWS CLI. Now, by default, this image will not really work the way we have used, for example, the Node image or the Alpine image. This image has a thing which is called an entry point. Essentially, when we're starting the image, there's already a program that's running with that image. And this is something that conflicts a bit with the way we're using images in GitLab. So we need to override that entry point. So for that reason, I'm going to move this to a new line. I'm going to write here another property, which is called name. So this is under image, and this is not a list. And below it, I'm going to write entry point. And here, I'm going to override the entry point with this square brackets and this quotes here. So then comes the script part. And in the script part, we are essentially writing, well, let's test if the tool is working. So typically, almost every tool will have the possibility of printing out the version. So the name of the tool is AWS. And then the version will be -- version. Now, what we're interested in is using AWS CLI in version 2. This is the current version. No other version is version 1, but we're definitely interested in using version 2. So for example, here from Docker Hub, you can go to the tags, and you can also specify a tag. If we don't specify a tag, we'll always get the latest version. But generally, it's recommended that you specify a tag and that you go with a tag. So for example, if I want to specify this tag, I'm going to copy the name of the tag. I'm going to add here column and then the value that I want to use. It's a best practice to always specify a tag. But of course, by the time you watch this, there will be newer version. Typically, anything that starts with 2 should be good enough. So let's commit these changes in a branch and see how the pipeline looks like. Now, right now, I'm getting an error. And if I'm looking inside the pipeline to see what's going on, there are some errors because the stage I have chosen, in this case, the deploy stage doesn't exist. So the pipeline hasn't been executed. So we still need to make some changes to it. So here where we have the stages, I'm going to add here deploy. So now we have the stage build, test, and deploy. Again, I'm going to commit and see if the pipeline runs. So now the entire pipeline has been successful. Let's take a look at the deploy job, see exactly what has happened there. And we can take a look at the logs here. We have used this AWS CLI image. And of course, we have printed here the version. So we'll see exactly which version we're using. I've used a tag. So with that tag, I'm going to always get this version. But sometimes if you don't want to specify a tag, it's still a good practice to log the version in the logs. Just in case, from one day to the next one or like 1 month later or something like that, your pipeline doesn't work anymore. At least you can compare previous logs with existing ones and see if there's any differences in the version that you have used for the various tools. I'll tell you right from the start that getting this upload to work will require a bit of learning and a bit of steps. So we're not gonna be able to do this right in this lecture. Gonna get some errors. Just as a heads up, but we'll be making progress toward that goal. So how do we upload the file? So let's continue editing this pipeline. Now, as I said, because you're going to need a few tries, I'm going to go ahead and disable the build website and the test website jobs. And that will ensure that we're only running the deploy to S3 job for the moment until we're ready and we have tested that the upload works. I always like to make things as simple as possible. And whenever I'm working with a new tool, I want to make sure that I don't make any mistakes or that I can easily understand what's going on. So for that reason, I'm going to leave aside this complexity with building and testing the website. We're going to only focus on deploy to S3. So we have here the AWS version. And then what you're going to use here is AWS. This is the name of the CLI tool. Then I'm going to specify the service name, which is S3. And then on this service name, we are going to use copy, right? So we are copying something to S3. Now, what are we copying? Well, for example, let's create a new file from scratch just to make sure that everything is working properly. So how do we create a file? I'm going to use echo. And I'm going to write here, hello, S3. I'm going to put it inside, let's call this test.txt, right? So we are putting hello S3 inside this file. So we have this file. So we know exactly what we are uploading. And the question is, where are we uploading this? Where are we uploading this to the bucket that we have created? Now, for that reason, we need to have the bucket name. And if you still have your bucket open, you'll be able to see here the destination. Now, this is my destination. You will have a different bucket name, of course. So I'm going to go ahead and simply paste this. So it's S3 column / the name of the bucket. And then we have to specify the name of the file. So in this case, I'm going to keep the same name. It's going to be test.txt. So we are taking this file that we have created inside GitLab. We are uploading it to this bucket, and the name of the file will be the same in this case. Let's give it a try and see how it works. Because we have disabled the build and the test stages essentially, we now only have the deploy to S3, so this makes the entire pipeline execution much faster. But let's take a look why this failed. So what we did, we're still printing the AWS version, and then the last command that we have executed is this one. And I cannot stress how important it is to go through the logs and try to understand what has happened. So it says here upload failed, trying to upload this file to this location, and it says the error essentially is unable to locate credentials. The thing is, how is AWS CLI supposed to know who we are? I mean, if this would work as it is right now, we should be able to upload files to any bucket that belong to other people, or to delete objects from buckets that belong to other people. So we need to tell AWS CLI who we are. And this is what we're going to do in the upcoming lectures. And in order to have the entire context in terms of this, we have to go through a few stages of preparation. As it stands right now, there's something about this pipeline that I don't like. And that is because we have something inside here that may change later on. And I would really like to make this configurable and not to have this information inside here. At the beginning of the course, we looked at the defining variables, and I've shown you how you can define some variables within the pipeline. There's also another place where you can define variables, and for that, I'm going to copy this value and I'm going to go inside the settings. So from your project, you can go to settings here on the right-hand side. And what you're going to do here is select CI/CD. And right here in the middle, you will see variables. I'm going to expand this so that we are able to add variables. Now, typically here, we tend to store passwords or secret keys, but I'm going to use this bucket name as an example for some important features you need to know about. So let's go ahead here and click on add variable. And I'm going to name my variable AWS _S3 _bucket. And the value will be exactly what I've copied from the pipeline. Now, there are some additional settings here I want you to pay attention to. There are two flags. One of them is typically enabled by default, and that is protect variable. This flag alone is the single cause for a lot of confusion and a lot of wasted time for people who are just getting started with GitLab. I just wanted to point this out. If this flag is enabled, this variable that we have defined here will only be available to protected branches. So for example, the main branch, that is a protected branch, that information will be available. In our current branch, I created here a feature branch for working with AWS CLI. If I leave this flag on and try to use this variable there, it will not work. Typically, the idea here is, let's say you have two environments. You have a test environment and you have a production environment. You may have different credentials for each systems for security reasons. Now, you typically want to keep the protected variables for the main master branch, which deploys to production. In this way, you ensure that nobody has the credentials to accidentally deploy to production from a different branch. So this is a security measure. Now, we are using branches and we are using the services directly. So at least at this stage, we're going to go ahead and disable this flag because we don't want to protect this variable because it will not be available in our pipeline execution as we are running this on a branch. The second flag is disabled by default. This is something that will be masked. In order to mask a variable, this is particularly useful for password. So for example, if you accidentally try to print one of these variables in your code, it will not appear there. It will just appear like a masked out with like simply stars. It's okay to have, for example, usernames or other things like this bucket name. We don't need to mask this because it's not really a secret. But if we had here a password for a password, it would make sense to mask this. So for this variable, I'm going to disable the protect variable flag, and I'm going to disable the mask variable flag. Many people think that if you don't have the protect variable flag, the variable is somehow public or unprotected. That's not the case. It's simply available for all the branches inside the project. And at this stage, that's totally fine. I'm going to change this a bit later on. But at this point, that is fine. I'm going to go ahead here and add the variable. You will be able to see it here being added. And of course, if you need to make changes to it, you can go ahead and make changes from here. Going back to the pipeline, instead of having this value, I'm going to start here with the $, AWS S3 bucket. So the name has to be exactly as you have defined it. And don't forget to put the $sign in advance because this is what makes this a variable. We can run this pipeline again and see how it looks like, see if we notice any changes. Now, if we're looking at the logs, we should be able to notice something interesting. So what is interesting about this is the following. We have the same command, but now inside the command, you notice this variable. So when we're running the command that's being logged here, this doesn't change. It will still show you with the variable. So it may seem that it's not resolved. But actually, if you're looking here at the error that we're getting, you will see here that the variable has been resolved. An indication that the variable has not been resolved is, for example, not seeing this text at all. So I invite you to play around with the protected flag and to run the pipeline again to see what's happening. And you should be able to see here that after S3, you will get 3 forward slashes. You will not be able to see your bucket name here. So let's go back to what we wanted to achieve to actually upload this file. And we're still getting this error, unable to locate credentials. So what should we do? Should we put our AWS email and password somewhere in these variables so that AWS can locate them? Well, you're getting pretty warm with that. Yes, essentially we have to provide some credentials but those credentials won't be our regular email and password because that will be highly insecure. Whenever we're using a service, we try to give limited access to that. So in order to give this limited access to services, in this case, we only need S3. There is also a service that manages that. So if we go back here to AWS and search for services, the service that we are interested in is IAM or YAM. And this is essentially an identity manager service that AWS offers. So let's go inside it and see what we can do. So first of all, if you didn't activate multi-factor authentication, you're going to get this warning, and I definitely recommend that you do that. This is just a testing account for me, which will be very short-lived. So for that reason, I didn't do that at this point. Now here from this service, we can create new users. Essentially, we want to create a user that will be able to connect to S3. So from the left-hand side here, let's go to users. And I'm going to add a new user. So we have to give here this user a username. Can be any user. Typically, I'm using something so that I know why I created it. So I'm going to call this GitLab. I know exactly that this user is intended for GitLab. And we have to select an access type. Now, what we are interested in is also called programmatic access. So we're going to click this, and you will see here that this enables an access key ID and secret for AWS API, CLI, and so on. So we're interested in having this for AWS CLI. So this is why we are creating this user, and we are enabling this programmatic access. We don't need a password. We don't need this user to have access to the management console like we do. So for that reason, that's sufficient. Let's go to the next part, which is the permissions. So essentially, the permissions tell what the user is allowed to do. And permissions in AWS, I'm going to say it's not an easy topic. So I'm going to go the most straightforward way. I'm going to attach an existing policy. So I'm going to go here to attach existing policies. And in this search bar, I'm going to select S3. I'm going to search for S3. And you're going to get some predefined policies. So policy is essentially like a set of rules that we can apply to a user. And the set of rules that we're going to use here is Amazon S3 full access. So essentially, we're going to give this user access to everything that is AWS S3. So we should be able to create new buckets, should be able to delete files, and so on. So a bit more than what we actually need for this use case. But just to simplify things, I'm going to give this full access to the user. But of course, this is a topic on its own. Let's go to the next page, which is the tags. We don't need to add any tags here. And then we'll be able to review what we're trying to do. And we can go ahead and create this user. So now we have successfully created a new user. And AWS has created something for us. And that is an access key ID and a secret access key. To put it in plain English, this is like a username and a password. You will see here that the password is not even displayed. So what are we going to do with this information? So first of all, let's go ahead and copy the access key ID. Go inside GitLab. Again, gonna go to settings, CI/CD. Gonna expand here the variables. And let's go ahead and add a new variable. I'm gonna start here writing AWS, and you will see there are already some predefined things that pop up. So one of them is AWS Access Key ID. This has to be written exactly as you see it here. If there's something that's different about this, AWS CLI will not be able to pick up this variable. It will look exactly for this variable name and will automatically pick it up without us doing anything else. So it has to be exactly as it is. I'm going to paste here the value. Of course, this is as per my account, so you'll have a different value. And I'm going to disable the protect variable flag because we want to be able to use this in a branch as well. And I'm going to go ahead, add this variable. And going back to AWS, I'm going to also show here the secret access key. Of course, I'm going to delete this right after the recording, but I'm showing you just to know exactly how it looks like. It's also important that you don't add any spaces or anything like that. So I'm going to copy this secret access key. I'm going to go here, add a variable. And I'm going to start typing AWS secret access key. And I paste the value here. I'm going to disable the protect variable flag and click on add variable. Finally, there's still another thing that we need to configure, and that is our region. So again, I'm going to add here a variable. Start typing AWS, and we have here the default region. So when we're setting this variable, all services that we use will be in this region, and we don't need to specify the region all the time. AWS knows exactly where this bucket or any other service is located. And we cannot simply write here anything. We have to write exactly as AWS uses it internally. So what do I mean by that? Well, let's go back to the AWS console. And you will see here the S3 service and recently visited. So this will make our life easier in terms of grabbing this information. And for example, for my bucket, this is in US East, North Virginia. What we're actually interested in is this code. So I'm going to copy this information and paste it here. So this will be the default region. And again, I'm not going to protect this variable. And I'm going to add it here. What I forgot to do in terms of the secret access key is I haven't masked it. So it would be an idea to go back to it, click on this edit, and you will see here this flag. Because this is essentially a password, I'm going to click here this flag to mask it. I'm going to update it. And then you will also have here an overview, like which one of them is protected, which one of them is masked. And of course, if you need to inspect some of these variables, you can go back and click on them and you will be able to see the value. But at least on this overview here, they are hidden. There's also this possibility of copying the value without revealing this. Can be useful as well, or you can click here on reveal values and they will be displayed. All right, so it seems that we have everything in place now. At least we have these credentials. And because we named them the way we named them, AWS CLI will automatically pick them up. So there's actually nothing that we need to change in our pipeline. So for that reason, we can simply go ahead and rerun the same pipeline once again. I'm going to go here to CI/CD pipelines. Go here to the job that failed. And here I can simply click on retry. So this will start the exact same job once again. All right, so this already looks so much better. The job has succeeded. We don't see here any errors. AWS CLI is telling us which files have been uploaded. So we could jump into S3. And take a look inside our bucket to see if we have any files here. You will be able to see here our test.txt file right inside here with say when it was modified and so on. We can download it if we need to. But essentially, this has been the first major step in terms of interacting with the AWS cloud. All right, so we have made some progress and we have managed to finally upload this file. But if you remember, we have an entire website with a lot of files. So, going file by file and uploading that is not really the way to go. So how can we make sure that whatever we have inside the build folder is going to be synced to our bucket? Now, if you remember, in the beginning, I mentioned the documentation, the reference for the AWS CLI. Essentially, for any service, there is here documentation, there is here an additional command. So we have used AWS S3 as the name of the service. So in this list of services here, you will find S3 somewhere. So here we go. This is S3. So I'm going to click on it. I'm going to be honest with you. In the beginning, this documentation will look very scary. But if you take a bit of time, if you have a bit of patience and you go through the documentation, this is the way to really master the CLI commands that you will be using. And this doesn't only apply to AWS CLI, it applies to any tools out there. So reading the documentation, looking at all the parameters, everything that you can do with this is really super helpful. So for S3, you will see here a lot of documentation, but also at the end, you will see here a list of available commands. So we have used cp for copy, so we've copied this file. And it's also definitely possible to copy an entire folder. But I wanted to show you also a different command, which is sync. Now, typically, syncing something means that whatever we have on one side, we have on the other side as well. For example, to ensure this with copy, we'd first have to remove the folder just to ensure that we really have everything. So for example, if we added the file or we have removed the file, we don't want to have those files on S3 anymore if we don't have them on our website anymore. So for that reason, using something like sync, which ensures that all the files are in sync, does make a lot of sense. So we can go here on sync and we'll tell right from the description, it syncs directories and essentially it ensures that whatever we have there on one side is also available on the other side. So how do we use this? Let me demystify this and take a look at our existing pipeline that we have here. So first of all, we're going to give up on this test file that we have uploaded here. This was just for testing purposes and to make sure that we have everything set up correctly. So we're going to use here AWS S3. So the command will be sync. So what are we syncing? We're syncing the build folder. So instead of that file, we're going to have an entire folder. And the question is, where are we syncing this? We're syncing this to the bucket. So we're going to remove this part here because we are going to put it directly inside the root. And additionally, we're going to also add a flag. So if you're looking here through all the options that are available, one of the options should be --delete. It will essentially ensure that if we delete some files during our build process, which existed previously in previous builds, that are also deleted during the sync. So if I had a file in the build folder, I synced it in the last build, then I later removed that file, I want that one removed from S3 as well. So I'm going to add here, delete. So this essentially should be enough to upload our build folder. Now, in order to get this to run, of course, we have to re-enable our previous jobs. So now build and test are enabled. I'm going to commit these changes and see if this command worked. And the pipeline is now successful, and we're most interested in this last job that we have executed. And now if you're looking at the logs, we'll see exactly which files we are uploading. So we'll see here, uploading this, uploading that. So these are all the files that we have inside the build folder. What's also important to notice is, you notice here this delete. So this file is then deleted because it no longer exists in the build folder. It actually never existed in the build folder. But Sync detects that this file doesn't exist there and says, okay, if it doesn't exist in the build folder, it doesn't make any sense to stay on S3, and goes ahead and removes it. So let's take a look at the S3 service. I'm going to refresh this page and take a look to see how it looks like. So now we are able to see all the files that we are actually interested in. They all have been uploaded here. And we made a very important step towards hosting our website in the AWS cloud. Now, currently, the files that we have uploaded here, they are not publicly available. Whenever we create a bucket, by default, it will be private to us, so nobody else external has access to it. Actually, that's kind of like the normal use case. You don't want the files that you're putting here to be available for everyone. But of course, there are use cases when you want to make these files accessible to anyone else. And actually, quite a lot of companies are using S3 for storing files that they offer for download because it's so much cheaper than hosting them on their own website. Now, in order to make this bucket publicly accessible, we need to change a few things. And I'm going to start here with properties. And actually, what we are definitely interested in is enabling static web hosting. So again, I'm here in my bucket inside properties. right at the end, there's static website hosting. I'm going to go ahead here, click on edit, and we're going to enable static website hosting. And the hosting type will be host a static website. And there are also some settings here that we are going to input. Websites typically have an index page, which is the start page, and also they have an error page. For this application that we have, the index page and the error page are the same, and this is the index.html file. If you look inside the bucket, you should see the index.html file. So this is exactly what we're going to have here for the index and the error. So I'm going to save these changes. And we're still under properties. And if we go back here at the static hosting part, you would see here that now we have an address. So now our website is hosted on AWS. We could also get the domain and point this to this address. But for what we're trying to do right now, this is more than enough. So we can go ahead and click on it. And in the beginning, we're going to get this error. And there's still a few things we need to configure. Don't worry about it. Just wanted to point out the address and where you can view it. So let's see which other settings do we need to make. I'm going to go here to permissions. And you will see here the first thing that appears is access. Bucket and objects not public. Whatever we have here in the bucket is not public. So this is why even if we have enabled static website hosting, we still cannot access this information. So let's take a look at how we can enable public access. I'm going to click here on edit. And I'm going to disable this block all public access and save the changes. And again, because this is like a major thing, AWS really wants to make sure that we know what we're doing. So I'm going to enter here confirm. Now, if I'm going to the website, we can try a refresh and it will still display the same error page here. So there's something that's still not working properly. What we need to do, in addition to what we did here in regards to the public access, is a bucket policy. Now, essentially, we need a policy for the objects that are inside the bucket. Don't want to get too much into the details, but essentially, we need to write this policy. So we can go ahead here and click on edit. This is like a policy generator. Now, what you see here is JSON, and this is the format in which this policy will be written here. There are a few things that we need to change about this policy. So essentially, we can go ahead here and add an action. So let's search, for example, for S3. I'm going to select it here. And the permission that we are looking for is essentially get object. I'm going to click on this, get object. But additionally, there are also a few other things that we need to change here just to make sure that everything is working properly. And these changes will be made in text, but you also find a template in the course notes just in case something doesn't go well. You will have the possibility of using that. So essentially, I'm going to give here a name, and I'm going to call this public read. This is just a name to identify this policy. And the principal here, we need to be put between double quotes. And I'm going to put here this star. And then the action will be get S3 object. That's allowed. The effect is allow. And the resource, we also need to specify the resource. And the resource is our bucket. I'm going to copy this name. It's essentially the address of the bucket. And I'm going to put this here also in quotes. And I'm going to add here, very important, a / and this star, which essentially means that everything that is in this bucket can be retrieved, get object. It is allowed. So this is essentially our policy for public reading. All right, I agree. It's not so easy for beginners, but let's hope we haven't made any errors here and that it will work as expected. I'm going to click here on Save Changes to apply this policy. You will see here warnings all over the place. You will see under the bucket in red, publicly accessible, access, public. So AWS is really trying to tell you, hey, watch out. If this is not what you intended, or this is not what you want, this bucket is publicly accessible. So really, really make sure that you know what you're doing. But for us, it's fine. This is what we wanted to have. And now, by refreshing this page, we're getting the website that we have created. And now, congratulations. Really, this is absolutely amazing. We created a pipeline that now takes every commit that we make and deploys it in the AWS cloud. We take it through all the stages, but we only have to make the change and the entire process is automated. So if you manage to follow along up to this point, wow, I'm sure that you have learned so much. And trust me, we're just getting started. There's still so much more to learn, and I'm super excited about the upcoming steps. Now let's go back to the pipeline that we have designed now. And I'm still here in an open merge request. And if I'm looking at the pipeline, I have here all the 3 stages. So the build, the test, and the deploy. Now, if you think about it, this really doesn't make a lot of sense. And what doesn't make sense is to deploy to S3 from a merge request or from a branch. Now, if we think as S3 being our, let's say, our production server or production environment, then it means that anyone who opens a merge request and tries out some small changes, if the build and the test pass, this will automatically get deployed to production. And actually, this is not what we want. We want inside a merge request, or as long as we are in a branch, we just want to run the build and test, essentially to simulate the execution of the main branch. And then only when we merge this, we want to run the deploy. So we want to deploy to production. So in order to achieve this, we still need to make a few changes to our pipeline. Now, this is how the configuration looks like at this point. And the changes that we need to make are here in the deploy to S3 job. Now, how do we exclude this job from this pipeline, which is running on the branch, and to ensure that it only runs on the main branch? GitLab has this feature which is called rules. Now, rules allow you to create really complex conditions, and I won't get into those, but we're going to use a relatively simple condition which will check if we are on the main branch or not. Now, in order to set up rules, we're going to go to the deploy to S3 job. And what I'm going to write here is rules. So this is a completely new keyword. And here we can define a list of rules. Now, we're going to add only one rule. And this will be a list. So you notice that I'm starting a list. And then we have here an if column. And now after the if, we can specify a condition. So in a condition, we're typically checking if something equals or does not equal something else. So in this case, we want to check if the branch we are currently at, so we have here something, I don't know where we're at, equals, so we're going to make 2 equal sign, the main branch, right? So if we are on the main branch, only then run this, right? Now, we don't want to put here something hard-coded, so we cannot know in advance like which is this branch name where we are currently evaluating this condition. So in my case, I mean feature deploy to S3 or something like that. So it doesn't make sense to add that there to check this. It needs to be dynamic. So in order to have something dynamic, we need to use some variables. Now, luckily, GitLab comes with some predefined variables. And one of these variables is CI commit ref name. So I'm going to search here for ref name. You will see here. So CI commit ref name, this will give us dynamically the branch or tag name for which the project is built. So we can use this as a variable. And I'm going to write here $, this one. So this will be evaluated to our current branch. Now, with any of these variables, if you're not sure what they do, how they look like, simply use here echo And just keep something like this for debugging purposes in your pipeline until you get familiar with the values that you're having. I'm going to remove it because I don't need it. But for you, definitely recommend use echo to inspect the different values that you're using. If you were on a different branch, this will be something else. So if this equals main, then we're gonna essentially run this job. Otherwise, it will be excluded from the pipeline. Still, having something hard-coded here is also not something that we like doing. Yes, we could keep here main, but there are also variables that can handle this. So another variable that we can use is default branch. So it should be CI default branch. And this variable will dynamically give us the name of the default branch. So if later on, for whatever reason, we decide to switch from master to main or from main to something else, then we don't need to worry about these pipelines because the default branch will automatically get updated in this variable. And then we can use it directly here. So again, I've added here another variable, which is the CI default branch. So now everything is dynamic. So this rule makes sure that when the current branch equals the default branch, this code gets executed. In our case right now, for main will have this job. In other pipelines, this job will get excluded, not be part of the pipeline. So I'm going to commit this, and I'm going to take a look at the pipelines after this. So what I invite you to do is to go to CI/CD pipelines. And now our pipeline only contains 2 stages. So we have the build and the test stage. The deploy job was completely removed. I can also inspect the merge request and take a look at what is going on here. And also I see that this pipeline has been updated. It contains only build and test. So at this point, I would say, okay, I'm pretty confident that this functionality is working properly. Gonna click here on merge. And also let the main pipeline run. So again, if we're looking here, CI/CD pipelines, we will now see that the main pipeline has started. So this is on the main branch. And now this pipeline contains the 3 jobs required. So we have build, test, and deploy. So now the main pipeline is also working. We have deployed again to S3. But how do we know if our website is still working? Again, we could go to the address again, hit the refresh button, check again if it's working. But again, that's not really the point of automation. We want to make sure that the entire process is automated. So if this is a worry that we have, like is the website still working that we have deployed, it's probably time to add another stage and to test after this deployment if everything works correctly on the website, or at least as much as possible. So let's open up the IDE and take a look here at adding another stage. So we already have here build, test, and deploy. So probably the next stage should be, let's call it post-deployment. So this will be after the deployment. And then it's probably time to also add another job. I'm going to call this production tests. And I want to make sure that the stage is the right one. It's post-deploy. And what I'm proposing is to simply run a curl command. So that's pretty similar to what we did here. So I'm simply going to go ahead and copy this. Of course, this has to be under the script block. And there are a few things that we need. First of all, we need a Docker image that has curl. And one option would be to search again Docker Hub for such an image. But essentially, any Docker image that has curl would be sufficient. So I can go ahead here on Docker Hub and search for curl. And what I've used in the past is curl images curl. But probably also one of these verified content images is probably just as good. So the address to this image is this one. So this is what we need to do without the Docker pull. So we have here image. I'm gonna paste, remove this Docker pull. That's the name of the image. And because curl is such a generic tool, don't need to specify a specific version. What we're doing is pretty basic, and I'm pretty sure it's not gonna change very soon. The other thing is the address, right? So the address where we have deployed this, and this is available in S3. So if I'm going back in S3 to our bucket, I'm looking here at properties, and right at the end, this is the address, right? So I can go ahead and copy my address, go back to the editor, and I could paste it here, right? But again, we had a discussion about like not having, things that could change later on inside our pipeline or have it all over the place. So again, let's go ahead and define a variable. Now this time I'm gonna define a variable within the pipeline itself. That's also totally fine and also a way on how to do things. I'm gonna define here variables block, and let's call this variable app base URL. Of course, you're free to name it as you wish, column, and then I'm going to paste here the address to it. So this is now the full address to it. So all I need is this. This is the variable name. And here, instead of writing something like this, you can simply go ahead, use curl app base URL. I'm going to search for React app because this is what we have actually in the body of the index HTML that we are grabbing. This should be enough, at least to test that what we have on S3 is still reachable, that at least this text is still available there. Additionally, we need to make another configuration because otherwise, as it is right now, this will also run inside a branch. So I'm going to copy this rule that we have here on deploy to S3. The same rule is valid here. We want to run these jobs only in the main pipeline. So I'm going to go ahead, commit these changes, and merge them into the main branch. And I'm anyway pretty confident that this pipeline will work without any issues. So there's no additional review that I need at this point. I'm going to simply merge when the pipeline succeeds. And I'm going to grab a coffee until this is merged. So after a few minutes here in the merge request, we'll see a few things. So first of all, we have here the pipeline for our branch with 2 stages. We have the build and the test. That's it. After we have merged this, then the pipeline for the main branch has started. And this pipeline then has 4 stages: build, test, deploy, and post-deploy. So it's essentially the stage that we have added right now, and this contains the production tests. So let's take a look at them to see what has happened here. So we have executed this command. Curl was able to download the website, has passed this information to grep, and grep has searched for React app in the text, and somewhere here was React app. So for that reason, everything worked out successfully. So we know that website is still there, it's still working. So that's perfect. So let's take a minute and take a look at what we did so far. So this is our main pipeline, right? This is the pipeline that now deploys to AWS S3. And we have the build and the test. This is what we essentially call continuous integration, right? This happens also in the merge request, but also here we are rechecking that our build is still working and that the tests are executed. Here, the second part, this is the CD part in CI/CD. Now, CD can mean continuous deployment or continuous delivery. I'm going to explain in a second what that means. Right now, we're kind of doing continuous deployment in the sense that every commit that goes into the main branch will actually be deployed to production. We have automated the deployment to S3. And we said that our S3 bucket, it's hosting our website and is essentially our production environment that the whole world can see. Now, this is a very simplistic view on CI/CD. Now, quite often, pipelines also have a staging environment or a pre-production environment. Essentially, if we make changes to our deployment to S3 and something doesn't work anymore, we're not really testing this before, and the main branch may still produce some errors. And again, we come back to the same problems we had when we did CI, when nobody else can work on a project anymore. So for that reason, it kind of makes sense also to add another environment. At least if there are some issues with the environment before production and the main pipeline breaks, at least we haven't affected the production environment. So it's still good. Right now, we're just deploying anything and we're testing afterwards. What is a staging environment? So a staging environment is essentially a non-production, usually non-public environment that is actually very close to the actual production environment, right? So we want to keep things as similar to the production environment as possible. Quite often we use automation to create these environments and to ensure that they are really identical. We haven't done that. We have used manual work to actually create the S3 bucket. And we did some automation afterwards. But ideally, we would create this entire infrastructure automatically. So the idea is to add a staging environment as a pre-production environment. Essentially, we want to try out our deployment on pre-production before we go to production. So in case it fails, the production environment is unaffected. The main two concepts I want you to be aware of is continuous deployment and continuous delivery. Now, with continuous deployment, as I said, every commit that goes through the pipeline would also land on the production server, on the production environment. With continuous delivery, we're still using automation, and every successful merge request again triggers the main pipeline, which leads to an automatic deployment to the staging environment. However, we don't go directly to production. There is like a button that you click in order to promote a build from the pre-production environment to the production environment. So these are like the differences between continuous delivery and continuous deployment. In upcoming lectures, we're going to get a bit more into them and you're going to better understand like what they really mean. So now it's time for you to practice a bit more. And at this point, I have an assignment for you. And the assignment is essentially you building a staging environment. And I want you to follow essentially the same process as we did when we created the production environment. And I also want you to make sure that you write some tests that ensure the environment is working as expected. Please pause the video and take this as an opportunity to practice along more, both with AWS and with building the pipeline. So I hope you had a good assignment and that everything is working properly. In this video, I wanted to show you how I would do something similar. So first of all, I'm going to start with creating the bucket. And I'm just going to copy this name that I already have. Click here on Create Bucket. And essentially, I'm going to call this staging. Essentially the same name, but I'm just adding staging to it. And in the beginning, I'm going to leave all settings as they are. And in the upcoming steps, I will essentially ensure that this bucket is public. So they are the same steps as before, and I'm not going to go again over them. So after a few clicks, I now also have this staging bucket also as public, and I've enabled website hosting, which means you can go inside this bucket, can go here to the properties, and then right here at the bottom, I will see this address, which we will need later on. First of all, let's begin with the name itself. So I'm going to copy it and I'll have to go inside GitLab and save it in a variable. So here in GitLab, I'm going to go to settings, CI/CD, go here to variables. What you'll notice here is that we already have an S3 bucket. Of course, that's kind of an inconvenient at this point. So we'll need to figure out exactly how we can manage this. But I'm going to go ahead. I'm going to also call it AWS S3 bucket. going to call it staging. I'm going to add this thing that will make it different. Essentially now we can protect this variable because we don't want to deploy from a branch anymore. So it definitely makes sense to have this protected. Masking it doesn't make any sense at this point. All right. So at least now I have this. I'm gonna copy the name so that I don't forget it. And let's go inside the project, open the web IDE, and start making some changes to the pipeline. Now, first of all, because this is a pre-production environment, we need to define another stage before we deploy to production. Let's call this deploy staging. And of course, what we need to do here is to define a new job. Now, most of this job is pretty similar to what we already have here in terms of deploy to S3 and also in terms of the production tests that we have here. So it kind of makes sense to copy everything that we have and paste it here again. And let's call this deploy to staging. And we can call this deploy to production. Just to have like more clarity in terms of where we're deploying and what we're doing. And also we need to have the right stage. So the stage name is deploy staging. Apart from this, we are using the same image. We still want to run this on the main branch. And the only thing that we need to adapt here is the bucket. So it's going to be AWS S3 bucket staging. And again, the tests that we have here, they can be called staging tests. We'll see here that the editor is complaining about a duplicate key. So that's a good thing because you know exactly what we need to fix. So then we have the staging tests and also here where we need another base URL. So that's also something that we need to consider. So I'm going to add staging to this one as well. And from AWS, I'm going to copy the URL. Paste it here. You can notice that we have two different URLs. So let's double check everything. We have added a new stage, deploy staging, which is before deploy, or we can even call it deploy production, right? So we have even more clarity. Just need to make sure that we are adopting this everywhere. So we have here deploy staging, and then we have deploy production. But then we have post deploy. Now, we also want to have this testing after the staging. So we need something like test staging, for example, and we can call this test production, right? So we're deploying to staging, we're testing the staging. If both of them are successful, then we go ahead and deploy to production, and after that, we test again the production. So let's make sure that we have the right stages. Otherwise, we're going to get some issues. So deploy production. Yes. Test production. Test staging. Deploy staging. We have the right bucket name. Here we don't have the right URL. We need to grab that as well for staging. All right, and all of a sudden our pipeline got a bit bigger, but no worries. One last check. Deploy staging, test staging, deploy production, test production. Deploy staging is the stage. We're using the staging bucket. Staging test, we're using the staging URL. Test staging, deploy production, test production. All right. I'm going to go ahead, commit these changes, and we'll see how they work in the main branch. And a few minutes later, after the main pipeline has also completed, we'll see now that we have here a bunch of stages. So after the tests, then we're deploying to staging, we're testing staging, deploying to production, we're also testing production. Of course, we could go ahead and combine the staging. So for example, because our tests are very simple. There's nothing that prohibits us from just putting this simple test inside the deploy job itself. So that will save us some stages here. But I just want to demonstrate like how a longer pipeline essentially looks like and what's the meaning of the stages. So most importantly now, if something happens with the deploy stage, the pipeline breaks here. Production environment is unaffected. We don't have to worry about it. So we have time to fix any problems in our deployment. If you're looking again at the pipeline, well, all this staging environment has really created a lot of duplication and all these variables with the bucket. Now we have AWS S3 bucket with staging. We also have this base URL and the staging URL. Obviously, we have now two environments, but we haven't really figured out a way on how to properly manage these environments. Luckily, there is a functionality that GitLab offers for managing these environments. Going inside the project, you will find here on the left-hand side, deployments, and inside deployments, there's this option environments. What is an environment? Staging is an environment. Production is an environment. Wherever we're deploying something, that is an environment. And it really makes sense to have these environments defined somewhere and to work with the concept of environment instead of fiddling around with so many variables. That's really not the best way on how to do that. So what I'm going to do here, I'm going to create a new environment and I'm going to call this environment production. And I'm also going to get the environment URL from the pipeline. So as you remember, this is the production URL. So let me get that. I'm going to save it here. And going back to environments, I'm going to create a new environment. And this will be staging. Again, I'm going back to the pipeline, copying the name of the environment and putting it here. What GitLab will also do is to keep track of deployments on different environments. Now, currently, we don't have any deployments, but we can directly open the environments from here. So in case we forget where our environments are, we can easily click on this open environment link. Especially for non-technical people that are also working with GitLab, it's easier for them to see exactly where is the staging environment, what's the URL. Don't have to ask someone. You can just directly go to the respective environment and see that respective version. So very, very useful feature in terms of environments. But what does it do for our pipeline? Well, I'll tell you what this will do. We're going to remove this from here, right? I'm going to go ahead. First of all, this is out. I'm not using this anymore. Second of all, I'm going to go back to settings, CI/CD. I'm going to expand here the variables. And I'm going to go here to this AWS S3 bucket. I'm going to click here on edit. And this is essentially our production environment. This is for production. And now we can also give a scope. So we can tell GitLab, hey, this variable is associated with production and not with something else. So we can essentially scope it. And of course, in this case, because we're using it in main only, we're going to also protect this variable. I'm going to go ahead and update here. And the same goes for this other variable, right? Now we don't need this staging added at the end. We can just call it AWS S3 bucket. And we're going to select here the staging environment scope and update the variable. So now we have two variables that share the same name, but now they belong to different environments. Now the idea is to do the following. We need somehow to adapt our pipeline. And let's begin here by deploying to staging. First of all, we have this AWS S3 bucket. So I'm going to remove here staging from the end. And additionally, we need to tell GitLab, hey, this deploy to staging, this is associated with the staging environment. So I'm going to say here, environment staging. There are still a few things I would like to change. First of all, the entire pipeline right now is too long. we still have these staging tests and production tests. And because this is just one curl command, we can just move it away from here. I'm going to remove this stage altogether. And all I want to do is to add it here on deploy to staging. So essentially, right after you have deployed, we're also using this curl command. It's pretty similar to what we're also going to do on production. But as you probably noticed already, this app base URL doesn't exist anymore. We have removed those variables. And we need to find a way to get our environment URL. And luckily, again, GitLab to the rescue. There is a variable. I'm going to go ahead and search for environment. And I'm going to have here the CI environment name, environment slug, environment URL. So this is what we're interested in, the environment URL. I'm going to copy this. And I'm going to put it here in the curl command. So we're going to send the curl command directly to the CI environment URL. Same goes to the production, deploy to production. I'm going to add it here. So in this situation, the production tests, they also don't make any sense. So I'm going to remove them. And all these extra stages that we have here, test production, it's not going to be needed. Test staging, it's not going to be needed. So now we have a much more simpler pipeline, but we're still achieving the same thing. Most importantly, we are using these environments. We still have an error inside here, but I'm just going to commit these changes, let the branch pipeline run, merge these changes into the master. And we're going to take a look at the main pipeline to see which errors we still have there. Now, if you're looking at the main pipeline, you will notice something interesting. Deploy staging has passed. It's working perfectly. You will see here curl CI environment URL. It's fetching the page. It's passing. However, if you're looking here at deploy to production, it's all of a sudden complaining. It's saying here that AWS S3 bucket, parameter validation failed, invalid bucket name. So what's going on? Well, the following thing has happened. We somehow did not associate this with an environment, or the environment is not correct. So we need to go back and see why this job does not have access to this environment variable. I'm going to go ahead here and I'll take a look again at the configuration to make sure that the configuration itself of the job is correct. What do we have here? Well, we have deploy to production. But as you can notice, I haven't defined an environment, right? So I have defined an environment for deploy to staging, but I haven't defined an environment for deploy to production. If you're looking here at the variables, you will see that this AWS S3 bucket is now scoped only for production. And because this job doesn't say anything about production, this environment is not exposed in the production job. So to be able to solve this, we also have to add here environment production. So I'm going to go ahead and copy this, and the environment will be production. And of course, unfortunately, this time we have to go again through all the stages. The merge request and committing this in the main branch. And just a few minutes later, the entire pipeline will then succeed. So we have deployed to staging, we have deployed to production. Everything seems to be working fine. We can take a look at the jobs to see what they're doing. And we'll see here that everything worked out without any issues. And of course, we can also go here to deployments, environments. And here we are able to see the staging environment and the production environment, and we can easily open them. And we can see like what was deployed, when was it deployed. So it really keeps track here of the different environments and the deployments that took place. So we'll see here on production, there's only one deployment. On staging, we have 2 deployments that we have committed. So we are essentially keeping track of what is going on these environments. You know what? I'm still not super happy with this pipeline. I mean, generally when I see that a lot of things are repeating, that kind of makes me wonder if there's not a better way. So if we're looking here at the deploy to staging and we're looking at deploy to production, well, essentially at this point, because we have used all these variables, these jobs are almost identical. The only thing that is different is the different stage, the different job name, and we're specifying the environment. But the rest of the configuration is identical. And yes, the answer is yes, we can simplify this even more. So essentially, we can reuse some job configurations. So I can go ahead here and I'm going to copy this. And I'm going to go here and I'm going to define essentially a new job. I'm just going to call it deploy. But this will be a special kind of job. It will be a job that has a dot in front of it. And as you remember, we have used the dot notation to disable jobs. By having this, we can essentially have a configuration here. We don't care about the stage, right? We don't care about the environment. So this is something that is not in common with the rest. It doesn't even have to be a valid job configuration. We have just put here the parts that are really important for us. And then in these other jobs, we're going to keep what we need. So what we need a stage and we need an environment, and of course we need a job name. And this other part here, we can simply write something like extends. So this will be the extends keyword. And what are we extending? We are extending .deploy. That dot in front is very important, so don't miss it. And the same goes for deploy to production. I'm going to remove everything. I'm just going to keep here the extends and make sure it's properly indented. So deploy to staging, deploy to production. We now have two simple jobs here. Essentially, the deployment part is the same. This also gives us peace of mind because if we're making changes to the deployment part, we're only making changes here. So if we make a mistake there, the chances are we're going to be able to catch it before it goes to production. Let's commit this, give it a try, see how it works. It should essentially work the same as before. And after a few minutes, if we take a look at the main pipeline, we'll see that it works as it should work. It looks as before. And this is exactly what we expected. We didn't want to see anything else but the pipeline working. But now we have a much simpler pipeline configuration. I now feel it is time for another assignment. Now let me tell you my idea. Now we have this pipeline and we're testing with a curl command that specific text is on the website. And that's fine. It ensures that the website is still working. We haven't really made any changes to the website itself. We haven't added any text or removed anything. How can we make sure that, with what we actually build here actually lands on the staging and in the production environment, and it's not somehow a cache or something old there? Maybe the deployment is not even working and you're getting the older version and we think that everything is fine. So here's my idea. What if we add another file in our build? Let's call it version.html, for example. And inside there, we put a build number, something that is all the time different with each build. So for example, it will increment from 1 to 2, 3, 4, and so on. So that with every build, we can identify the build number and we can check which version has been deployed to staging and production. How about this idea? And in order to get you started, I'm going to show you how to get this information inside there, how to get this build information, this dynamic part. Maybe this is something that right now you don't know exactly how to do it. So no worries, I'm going to get you started, but the rest of the assignment, you will have to figure it out on your own. And trust me, you already know all the concept needed in order to implement something very simple. So I'm going to go ahead here and define a variable, and I'm going to call this variable app_version. Well, essentially, let's say that this is our application version. So we want to have something like 12, 13, 14, and so on. Now, again, when we're thinking about something dynamic, we have to think back to the list of predefined variables that GitLab offers, right? So on this list, there are various variables that we can use, including something that is related to the pipeline ID. So if you're looking for pipeline underscore ID, find here some pipeline IDs that we can use. So these are variables that, of course, change all the time. They are injected by GitLab, so we can use them in our jobs. So we can get here like an instance level ID. This typically includes like very large numbers because there are a lot of pipelines on a GitLab instance, but you can also get like a project level ID. So this will be something we can easily relate to it, and we're going to see it increment all the time. So I'm going to get this variable, and I'm going to use it here. So I'm redefining this because I want to give it a bit of meaning. I could have used this directly somewhere. This is really your solution. But if I'm using here app version, I'm very clear that this is the application version that we're using here, not just some random ID. So that's it. I'm going to let you do the rest of the assignment. So just to recap, here somewhere in the build, add a new file, which is called version.html. Add that new file, put this app version inside that file, and then when we're testing our deployments, including staging and production, so here, create a new curl command that will check that that application version is actually available on that environment. Okay, so I hope that you have managed to solve this on your own. I already feel I gave you like quite a lot of hints, but just to make sure, this is how I would solve it. So let's go here to the build website. Apart from all these things that we're doing here, what I want to do additionally is to create this file. So again, in order to create this file, we have to first think about a name. So it's going to be inside the build folder, right? This is what we're deploying. And the name will be version.html. And what we're doing is we're taking this application version. So in order to get the application version inside the file, I'm going to use echo. I'm going to print the application version and then essentially going to redirect it to the file. So this is enough to create this file, to put it inside the build folder, which already exists. Yarn build has created that. And because this is dynamic, it will be available there. The next step is part of the deploy template. So we're working directly in the template here. So we can essentially duplicate this command. We're going to the environment URL, and we hope that we don't have a / already. I'm going to check that quickly. I'm going to go here to deployments, environments. I'm going to go to staging, click on edit. I'm noticing here I don't have a / so that's already good. And I presume that the production environment is also similar, but just to check, edit, I don't have a / Okay. So inside our configuration, I'm going to add here a /. I'm going to write here version. And what are we looking for? Well, we're looking for the application version. And because the application version is simple number, we don't need these quotes here. So we can just write grep app version, and that should work. So already as part of the merge request, as soon as the build has completed, I want to go inside this build website and I'm going to take a look here at the artifacts to see if this artifact contains this version.html file. So I'm able to see it here, version.html. It has a size that is not 0. That's a good thing. And we can also download all the artifacts or just look at a single file. So after clicking on this, somewhere here on the screen, it will open up this web page essentially. So this is the build number 35. It's pretty small, but you should be able to see it on screen as well. So this is part of the file. So it's already looking good. When this merge request is completed, I will also take a look in the main branch. Now that the main pipeline is also working, makes me very happy because I now have more confidence in what is going on in this pipeline. I have confidence that if I'm making a change, that change actually gets deployed to staging and production, and we have this additional check then in place to ensure that. All right, so let's recap a bit what we did. The first part is the CI part, continuous integration. The second part is CD, continuous deployment. Now we have a more realistic continuous deployment pipeline. We're testing something, and then we're first deploying to staging. We're making sure that on staging everything works, and after that we deploy to production. But what is a continuous delivery pipeline? This is exactly what I wanted to show you. Essentially, a continuous delivery pipeline is just a pipeline where we don't automatically deploy to production. Essentially, what we want to do is add here a button, and only when we are sure that we really want to make that change to production, we can click on that button and make that change. So let me show you how to do this. I assure you, it's super, super easy. So inside the pipeline configuration, the job that is affected by this change is deploy to production. So here on deploy to production, I'm going to add a condition, and the condition is when, and I'm going to write here manually. It's actually when manual, not manually. So this will tell GitLab that we only want to run this job manually. So we need some manual intervention. I'm going to commit these changes, and we're going to take a look at the final pipeline. Now this is the final pipeline, and I want you to notice something. For deploy production, this job now looks a bit different, right? If you look at deploy staging, you click here on deploy production, we'll say here that this is a manual action, and we have here an additional button, right? If we also go to our deployments and we take a look at environments, we'll be able to see here like what we have on each environment. So you'll see here, if we're going here on staging, this is the staging environment. And of course, here inside the staging environment, we can go ahead and write here version.html. So we're getting here on the staging environment version 40, right? So this is the version on the staging environment. And if we're opening up the production environment, it looks absolutely the same. But if we look at the version.html, we'll see that this is a different version, right? On staging and on production, we now have different versions because our pipeline has not deployed to production yet. So in order to deploy to production, we have to click this button. And only then will the deploy to production job start. So this is essentially the difference between a continuous deployment and a continuous delivery pipeline. What we have here is a continuous delivery pipeline. We're continuously building packages of software, we're deploying them to staging, but we're not automatically deploying to production without that manual intervention. For some organizations, this is mandatory, and this is why I'm also showing you. In some legacy systems, you cannot always deploy everything without checking a few things in advance. Now, if we're looking here, deploy to production has also completed. So we can take a look here. If I'm gonna refresh this website, I'm gonna get here version 40. And here on the staging, also version 40. So now both staging and production have the same version. Now, I hope that the difference between continuous delivery, what we did right now, and continuous deployment, where every commit that lands in the master branch gets deployed to production, makes more sense now. Hey, how are things going? Are you like the course so far? You're following along? Let me know by leaving a comment in the section below, or by sending me a message on Twitter or on LinkedIn or on any social platform you can find me. I would love to hear from you and to know how you're using this course. We're at the end of this unit, so I'm gonna grab a coffee and I will see you in a bit. So far, we have worked with a static website and deployed it to AWS. That is probably one of the easiest scenarios involving GitLab CI and AWS. However, modern applications tend to be more complex and most of them use Docker nowadays. So in this section, we'll Dockerize our website, and instead of copying some files to AWS, we'll be deploying an application that runs in a Docker container. To do that, we'll build a Docker image as part of the build process, store it in the GitLab container registry, and deploy it to a service on AWS called Elastic Beanstalk. So if you're eager to learn more, let's jump right into it. When we use a cloud provider like AWS, we can rent virtual machines that have a dedicated CPU, memory, and disk storage. And we can use any operating system we desire. But this also means that we are in charge of managing that machine. We need to ensure that it is secure and that all software running is updated. This is often too much overhead, especially for some types of applications. But there is a way to take away this complexity and focus only on the application we want to deploy. AWS Elastic Beanstalk is a service that allows us to deploy an application in the AWS cloud without us having to worry about the actual virtual server that runs it. This is a great way to reduce complexity, and it's probably one of the easiest ways to deploy an application in the AWS cloud. By default, Elastic Beanstalk can run Python, Java, Node.js, PHP, and many other types of applications. But it can also run Docker containers, which really gives us a lot of flexibility. We'll be running a web server application that serves our simple website files. So this time, instead of just uploading some files to AWS, we are providing the entire application, which is self-contained in a Docker container. I'm sure you'll be amazed by how easy it is to run an application here. In the background, we will be using a virtual machine, but we don't need to worry about managing it. However, at this point, I need to warn you about potential costs. While running these servers for a few hours or days will most likely be free or cost you only cents, if you let the service run for a month, you may get some unexpected charges on your card. Even if you're not actively using a service, once you have created it, it uses resources in the cloud. So stop any services if you're no longer using them. Find a way to set a reminder so that you don't forget about them. With that being said, let's start using Elastic Beanstalk. So let's go ahead and create an Elastic Beanstalk application. So I'm here in the AWS console. And the first step would be to search for Elastic Beanstalk. So I'm going to write here EB. And you will see here one of the results is Elastic Beanstalk. So since I have no applications here, I'm getting this Getting Started guide. So I'm going to click here on Create Application. So let's call this application My Website. You don't need to include any application tags. And here on the platform, there are different platforms that are supported. But what we're actually interested in is in the Docker platform so that we can essentially deploy anything we want. I'm going to select here Docker. I'm going to leave the defaults as they are. And the first step would be to start with a sample application. So we're not going to upload any code. We're going to let Elastic Beanstalk create this instance, this application. And after that, we're going to add our own application on top of that. So I'm going to click here on Create Application. It will typically take a few minutes to get this to run. And in the end, you should see something that looks like this. So what has happened here? Well, we have created an application and we have initialized a sample application that Elastic Beanstalk provides. In order to actually run that application, this wizard that we have used, this setup, has also created an environment. So we have applications, which is like an umbrella for environments. So if I'm looking here at environments, you'll be able to see here that we have an environment that is called My Website-env. It belongs to the application My Website, and then you get some information in regards to when this was created, under which URL is this available, which platform is this using, and so on. In order to see like what this environment is doing, we're gonna click here on it, and you'll be able to see here a link. So if you click on this link, this is the sample application that was deployed. So it's just an idea, tells you that everything is working properly, that we have nothing to worry about. This entire setup has worked without any issues. Now the question is, what has actually happened in the background? In order to understand that, we're going to go here to the services and going to take a look at EC. We're going to write here EC, and that is EC2, the service that we're actually interested in. And this stands for Elastic Compute. These are essentially virtual servers that we can create here, but we haven't actually created one. But if you're looking here at instances, you'll see that we have one running instance. And this instance is called my website-env. You'll see here which kind of an instance this is. So this is a virtual server that's running here, and this is the server that's actually running our application. Additionally, if you're going here to S3, we'll be able to see that we now have an additional bucket. So we still have our buckets that we have used for hosting the website, but now Elastic Beanstalk has also created a bucket. So actually what Elastic Beanstalk has done has created this required infrastructure in order to run the application. We didn't have to worry about creating that, but this is why it took a few minutes to create this entire thing. Now let's go ahead and try to understand how we can deploy something on your own. Like, how can we get our own application to work? And because we're using Docker, we need to provide a manifest file, essentially a file that describes the application that we're trying to deploy. So I'm here inside the project again. And if you go into the templates, you will find here a file called docker1.aws.public.json. And this is the manifest file that I'm talking about. It essentially tells AWS which container we want to run. Because we have selected a Docker platform, we can only run Docker containers there. And this is a public container. The name of the image is Nginx, which is a web server. But what we want to try here is to actually use this configuration, to use this file, and to deploy this application to AWS to make sure that this deployment process is working. And this is again something that we'll do manually at this point, just to make sure that everything works properly. So go ahead and download this file. And after that, let's go back to AWS and open up Elastic Beanstalk. And here inside the environment, we'll have the opportunity to upload a new version of the application. You will see here right in the middle, running version. This is the sample application. Then we have this option, upload and deploy, and we want to upload that JSON file. So I'm going to go ahead and select the file, and I can also write here a version label. This will be sample application version 1. That's totally fine. And I'm going to go ahead and click on deploy. And what will happen is Elastic Beanstalk will take this file and then we'll start a deployment. We'll start here updating the environment. Of course, this will take a few minutes, but in the end, what we want to see here is health status okay. We want to see that everything is working properly and want to see that this application has been deployed and is available at this address. And now we're seeing here status is okay, so health is okay. Everything seems to be working properly. You can also go ahead and refresh this page just to see here which version is running. You will see here that the running version is sample application 1. So this is exactly what we have deployed. We can open up this address and you will see here, welcome to Nginx. So this is the welcome page from the Nginx server, which we have deployed by having this JSON file, which describes which container we want to use with Elastic Beanstalk. So in order to actually deploy our website, we need to create a Docker image. We need to provide this JSON file. And of course, we also want to automate everything. So this is what we are going to do in the upcoming lectures. So how do we create a Docker image with our website? A Docker image is created by following a set of instructions, something like a recipe. We store these instructions in a file called Dockerfile. So let's go ahead and create one. So here from the Web IDE, I'm going to go ahead and create a new file. And you will see here in the suggestions, one of the suggestions is Dockerfile. So which are these instructions that we write inside the Dockerfile? First of all, we have to start with a base image. Essentially an image that we want to add something on top of it. In our case, because we want to deploy a web server with our files, we're going to start with the Nginx image. It is exactly the same image we have used in order to test our deployment to Elastic Beanstalk. So I'm going to write here from Nginx. And additionally, what I highly recommend is writing a version, so writing a specific tag. So in order to know which tag to choose, I'm going to go to Docker Hub. I'm going to search here for Nginx. I'm going to take here the verified content. So this is the official image for Nginx. I'm going to take a look here at the tags. And let's search for Alpine, because Alpine generally provides us with a very small Docker image. So what I'm searching here for is a specific tag. So this here would be a very good tag to use. Just as an example, I'm going to go ahead and copy that. And here in the editor, column, and the version. So you have to be very careful how you're writing this. It has to be something like this. So we're starting from this base image. So we have everything that is in the base image we have there. So we already have the application essentially. The application is the web server. Now the next step is to actually add our files, which are in the build folder, and to put them on this web server. And we do that by using the copy command. I'm going to write here copy. So what are we copying? We're copying the build folder. Then we have to specify where we are copying it. Now by default, there is a folder where Nginx will store files that we want to serve. And that folder has the following path: /user usr share Nginx and then HTML. So we're moving this folder inside the HTML folder. So this is everything that we need to do in order to build our Docker image. These are the only instructions that we need at this point. We're getting this base image, Nginx, in a specific version because we're using this tag. And then the next instruction is copy everything that is in the build folder and move them to this HTML folder. Just because we have created this Docker file doesn't mean that something will automatically happen. We still need to make some changes to our pipeline. And because we're already making changes and because we want to deploy to Elastic Beanstalk, we don't really need this S3 deployment anymore. So I'm going to remove essentially all the jobs that are related to S3. This includes deploy to production, deploy to staging, this deploy job, which is just a template, and also test website. We're going to introduce a better way of testing. So I'm going to remove all of them. And what remains is the build website. And of course, also the stages here, they can be removed. So what we're going to do is we're going to introduce a new stage, or let's call it package. And we're going to associate this stage with a new job. I'm going to call it build Docker image. And now the stage will be package. So how do we build the Docker image? Well, it's relatively simple. The command is docker build. I'm going to also add a dot here because that's going to make a reference to the current folder. And the current folder contains the Docker file that we have created. In order to be able to run this Docker command, we also have to define the image that we'll use. And the image will be Docker. Now, just using this Docker image will not work. We're going to get an error. The reason for that is the Docker architecture is composed of a client and a server. essentially what we have here, Docker, this is the client, and the client sends some instructions to a server, actually to the Docker daemon, which is the one who builds the job. And in order to get access to a daemon inside GitLab CI, we need to use a concept, and that concept is of services. I'm going to define here a tag, services, and this contains a list of services that we can start. And what we're starting here is actually a service called Docker in Docker. So you're going to see me using here this Docker in Docker tag. So this service is another Docker image that can build Docker images, going to be accessible for us over a network, and Docker here, which is the Docker client, will be able to talk with the Docker daemon, which is here inside this service. I know that now at the beginning, this may seem all a bit confusing, but this is like the minimum what we need in order to be able to build Docker images from GitLab. What I also like to do is to set some tags. So I'm going to go ahead and write a fixed tag for Docker and for Docker in Docker. So I'm here at Docker Hub, and this is the Docker image. You will find a link in the course notes because this is something that's not so easy to find actually. Not so many people are actually looking for Docker. And I'm going to use this version here. I'm going to go ahead and copy it. And I'm going to add it here to my job image. And additionally, there's another tag with Docker in Docker. And this is the tag that I'm going to use for the Docker daemon. I'm going to remove here dent. And this will be the Docker in Docker image. You'll see both of them have the same version. Additionally, when we're building images, we also like to specify tags like a label. This will help us identify the images that we create because we can create multiple images, of course. In order to tag images, we first have to specify an image name and also the tag. So we can use here -t. We're going to keep here this dot at the end. That's very important. Don't forget that. And what we'll use here is, this is the list of environment variables. And one of these environment variables is this CI registry image. So we're going to use here CI registry image. Don't forget to put a $, in front of it. This will build the latest tag. So this is a tag that always points to the latest image that we have created. And additionally, I'm going to create another tag which still contains CI registry image. I'm going to add here the $, in front to make it a variable. I'm going to add here column. And we're going to use the app version that we are still having here in our job. So we are creating two tags. So don't forget the dot at the end. This is super important. This is one tag that we are creating. And this is the second tag that we are creating. And these variables will ensure that we have the right name for our Docker image. Additionally, in order to make sure that we have indeed built these Docker images, we're going to use here Docker image and ls. Actually, we are building only one image, but we are tagging that image with two different tags, the latest and the app version. So this will show us all the images that are available with all the tags that are available in this instance. I'm not going to run this job only on the main branch. I'm just going to run it inside the branch. I'm still here in the branch playing around. So we're going to see how this looks like after we execute it. And once the execution is done, we're going to jump directly into the build Docker image and try to understand what has happened here. So we'll see there are a bunch of logs that have been generated. But most importantly, what we want to see here is which Docker image are we using. So we'll see here, this is the Docker image, which is Docker. And then we're also, this is new, we're starting this service with Docker in Docker. So the service will be available over the network inside this image that we have right now. This will give us the Docker client. And there are a lot of logs here, and they're not really so relevant. The interesting part comes when we're actually building the image. And you'll be able to see here, this is our command. There are some steps how these Docker images are being built. Docker works with the concept of layers, but we won't go into that. But this is exactly what's happening here is essentially every command that we're executing will create an additional layer on that image. We have successfully built this. So this is what you want to see. it has been successfully built. And then we have also the two tags that we have created. You will see here the latest tag, and this is also the version tag. Now, they both point to the same image, but they are different tags. And you will better see it here with this command that is listing images. So this is here essentially the name of the image. We'll see here the tag, and you will see here that internally the image ID is the same. So we have the same image, but with two different tags. So now we have successfully managed to build and tag our image. As you might have guessed, the Docker image that we have just built has been lost as soon as the job finished. The Docker image that we have created is not a regular file or an archive that we can just declare as an artifact and upload it to S3. When we want to preserve a Docker image, in this case, this Docker image that we have created here, we need to save it in a registry. For example, Docker Hub, which we've been using to find out tags and images that we can use, is a public registry with Docker images. However, typically our projects are not public, so it doesn't really make sense to use Docker Hub. So for that reason, we need a private registry. Both AWS and GitLab offer private Docker registries. And for this example, we'll be using the Docker registry offered by GitLab. And you'll see here on the left-hand side, packages and registry. And we're going to use here the container registry because Docker is all about working with containers. And of course, at this point, there are no container images stored for this project. So alone, just building that Docker image does not automatically add it to the container registry. Actually, this is called pushing. So when we want to save a Docker image in a registry, we need to push it to the registry. So let's go back and make some changes to our pipeline. So let's take a look. How do we push? So the command in order to push something is docker push. And we actually want to push all tags. So we're going to use here parameter --all -tags. And then we're going to specify here the CI registry image. So this is in terms of pushing. But where are we pushing? And especially if it's a private registry, don't we need to log in somehow? Yes, that's correct. So alone pushing, this will not work in our case. We need to do something before we push. And we're going to do it right here in the beginning, because in case there are some issues with the login, we want to know as soon as possible and not only at the end. So the command to log in is docker login. Relatively easy. And we're going to specify username and a password. For this service, we're not actually using our username and password that we used to log into GitLab. We'll use some variables again that will give us some temporary user and passwords. Don't really care so much about that, but essentially this is what we're going to do. So if you're looking here at the variables that are available, we'll find here CI registry user, CI registry password. First of all, where do we want to log in? This is the CI registry. So we need to specify where do we want to log in. And additionally, we need to specify our username and password. So we typically specify the username and password like -u, and then specify the username. And we're going to use another variable, CI registry user, with a $sign in front of it. That's very important. And additionally, we can specify password -p, and we'll see here CI registry password. So these are all the credentials that we need in order to log in. In more recent versions of Docker, just specifying your password like this is not really the best way to log in. You may get a warning, and it's possible that in future releases, this argument, this -p, will not be available anymore. So what I like to do is the following. I'm going to remove it from here. Just going to copy this variable. And actually what we can do here is we can say to Docker login, get the password from the standard input. And I'll explain in a second what the standard input is. I'm going to write here --password -std in. This is the standard input. So the standard input is essentially something that we are piping from another command. And that other command in our case will be echo. So we're going to echo this CI registry password, but we're not going to display it in the logs. We're going to use this pipe. So this will be available in the standard input for the Docker login. And Docker login will look at that standard input and we'll see, oh, okay, the password is coming from there. So we're going to grab it from there. Using it in this way will ensure that this password doesn't get exposed. But really for CI, in our case, it will not get exposed anyway. But it's anyway good to know. And this is why we have this construct here. So once again, we are echoing this password and we're sending it to Docker. And Docker login will know that this password is coming from the standard input. And apart from that, we have the parameter with the user. So Docker login, where are we logging in? To the registry. Make sure that all the variables that you're using here have a $sign before them. Otherwise, they will not be resolved as variables. So let's give this a try as well and see if our image lands up in the registry. The build Docker image job has been successful. We can take a look at the logs to see exactly which tags we have pushed. And you will see here, these are the tags that are available. So we had tag 46 and latest. And this is pushing the tags to the registry. So no errors here. And what we can do next is to go here inside the registry, inside the container registry. And we'll see here this root image. And if we take a look at it, we'll see currently we have two tags. We have tag 46 and the latest tag. It will also tell us the size of our image. Because we are using Alpine as a base image, also our images are relatively small. So that's definitely a good thing. So now we have successfully built this container. But how do we know that the application is actually working? How do we know if Nginx is serving our files, if we have the right files, and if everything is working as we think is working before we actually move on to the next step, which is deploying to AWS? So for that reason, it does make sense to do some accepting testing on the Docker container itself, just to make sure that we have everything as we expect. So with that being said, let's go ahead and add another stage. I'm going to call this stage test. And of course, we'll also have to add another job. And let's call this job test Docker image. I'm going to assign the stage test. And let's think about like how we can test this. Essentially, the way we're testing this Docker image is not much different than the way we have tested, for example, a deployment or any other things in the past. We can still use curl to do that. So for example, I'm going to write here curl. We need here an address, http column // we don't know the address, but then again, we can use grep to search, for example, for the app version, right? And of course, we can also search for anything in the page that a website has. But say, for example, here, we're going to check the version.html that we have. So just want to make sure that we have the right app version. I'm going to remove one of the $signs here. So what do we need? Okay, we need curl. So we need a simple image that has curl. So we're going to use curl images / curl. So that should be enough to get this. But the question is, how do we start this container, right? This is where the part that we have learned before can be very useful. And that part is services. So again, we're going to take advantage of the services to start the Docker container that we have just created. So we're going to write here services. And this time what we'll do is in this list, we're going to define the name. This will be the name of the image. And the name of the image is, of course, $CI registry image. And the tag will be the app version. We don't want to use the latest tag. We want to go exactly like what is the current tag that we want to see. So this will help us start the image. And additionally, what we can do is to specify an alias. An alias allows us to give a friendly name so that we know where this service is available over the network. So I'm just going to give the alias of website. And here in HTTP, the address that I'm going to use is simply website. So http://website. GitLab will take care of starting this Docker container, registering it in the network as website, and then we can simply call it in our curl script with website. I'm going to go to version.html, and inside we're going to search for the app version. So let's give it a try and see how it works. And a confirmation that indeed our Docker image is working properly can be obtained from this test Docker image job. So in this case, indeed we have checked that the Docker image is starting an HTTP server and that the files that we have uploaded, in our case this version.html, it is available there and it contains the application version that we expected. So with that being said, in this case, we now know that we have a Docker image that works and we can deploy it to AWS. If you remember the first time that we have deployed an application to Elastic Beanstalk, we have used this JSON file which described which Docker image we want to deploy. And in order to automate this process, we kind of have to do the same thing. In other words, to give Elastic Beanstalk this file. Now, whenever we're interacting with AWS services, we need to provide some files. Most of the time, we need to do that through S3. So we first need to upload those files to S3, and all other services can read from S3 and have that information. So in order to automate this, we need to generate essentially this JSON file, upload it to S3, and from there we'll tell Elastic Beanstalk to start a new deployment. So going back to the pipeline, what we need to do is to re-enable the deploy stage and the deploy to production job, this time focusing on deploying to Elastic Beanstalk. So let's go ahead and add a new stage, deploy. And of course, also a new job here, deploy to production. Since we'll be using AWS CLI, I'm just going to add the basic structure that we need to this job in order to be able to use AWS CLI. So we're using AWS CLI as a Docker image. We're overriding the entry point. This job is part of the deploy stage. We have set the environment to production, and we are starting our script. Now, if looking at the files here, we'll see here in templates that we have this dockerrun.aws.json. The name of the file is not that important. The format of the file is very important because this file tells AWS Elastic Beanstalk what we are trying to deploy. And it will say here that this is our image and this is our tag. So we have them here as variables. But additionally, because this is a private registry, we also need to provide some authentication information. And that authentication information is another file. So that file is this auth file. And in this auth file, we will need to add a token that gives access to the registry. And essentially what we need to upload to S3 is this file, dockerrun, and this auth file, which is actually linked from here. It's mentioned here, auth.json. So let's go to the pipeline and quickly add these files. So I'm going to simply paste here the configuration required. So now I've added this copy configuration to the script. So we're still using AWS S3 copy. It's pretty similar to what we did before in terms of copying files to AWS S3. So I'm going to skip a bit this part. Now, as you may have noticed, these files contain some variables. And those variables won't get automatically replaced. So if we upload the files as they are, they will not get replaced. Second of all, we don't even have the right path here. They are in templates and not in the current folder where we're executing the script, just as a second thing. But I wanted to show you something very important, and that is how to do environment variable substitution in files. And for that, we're going to use a very cool command. It is env, so from environment, subst. So relatively easy to tell what this does. It replaces environment variables. Then we need to specify, like, what is the input file, and we do it with this smaller than sign, essentially. And then we're going to go here and say something like templates and give here the name of the file. And then we will have to specify the output file that will be generated. And the output file will be this one. So the name of the file will stay the same. The location will change. It will be put in the current folder. And this is perfect for the next command that we'll be using. So we're doing this environment substitution, replacing all the variables here. For the auth file just as well. So just going to replace that there and there. So any environment variables that are in these files will get replaced. In order to use this command, we need to install a utility which is called getText. Now, this doesn't come directly in this Amazon image, so this is something that we need to install additionally. I'm going to use this package manager to install this dependency, which is called getText. And getText has this tool for environment substitution. I'm going to also add this flag here. This will essentially answer with yes any questions that this installer may ask, because we are in a way that we cannot interact with an installer. We're going to specify this and say, okay, just install it. If there are any questions, answer with yes, just to ensure that the installation process works without any issues. Now we have this, so we can do environment substitution. Of course, it's going to be very nice to actually take a look at these files. So we're going to use here cat, just to make sure that these environments were substituted as we expect them. And as a final check, we should also go in these files and make sure that we have all variables here. So CI registry image, app version, this is something that we already defined. So we have this information here. AWS S3 bucket. This is relevant for where we are uploading these files. Now, because we are using Elastic Beanstalk, and Elastic Beanstalk has already created an S3 bucket, well, maybe we should use that one. So I'm going to switch here to the S3 service. And what I'm going to do is I'm going to copy this name. Could have used this other buckets that we have created here, but I don't want to put any credentials in a public folder. So with that being said, I prefer to use this bucket that is not public. And here in the environment variables of the job, we still have this AWS S3 bucket for production. So I'm going to click here to edit it. I'm going to change here the value. I'm not going to protect this variable because I'm still in a branch, and I'm going to update this. So at least at this point, we have everything. Let's see this other file, the auth file. You'll see here in the auth file, there is this deploy token. Now, what is the thing? Well, we have pushed our Docker image in the GitLab repository, but AWS has no credentials to connect to it. And again, we're not providing username and passwords, not our account username and password. We will generate a token, and GitLab allows us to generate a deploy token that can be used by AWS to log into our private Docker container repository and pull that image. So in order to do that, from settings, we're going to go here to repository, and we'll see here deploy tokens as one of the options. And here we can create a deploy token. So we're going to name it AWS so that we know why we have created it. And I give the username AWS. And the permissions that we need is read repository and read registry. I'm going to go ahead, create this deploy token. This will be created here. This is essentially like a password, but it will only be displayed once. So I'm going to go ahead and copy this, and I'm going to create a new variable to store it. So I'm going to call this variable GitLab deploy token. And the format how we'll store this information is I'm going to write here the username, AWS, column, and then the password that I've just copied. I'm not going to protect this variable. but I can just as well mask it just to be sure. Now here inside the pipeline, we still need to do a small change to the pipeline itself, to the script itself. And the thing is, we need to convert this username and password to base 64, because this is what we need inside this configuration JSON. This is what AWS expects. And in order to convert something to base 64, it's relatively easy. So for example, say you have here a string, right? Hello. You can convert it to base 64 by simply piping this and writing here base 64. This will output the string encoded as base 64. Now, of course, we don't want to have anything hard-coded here. This is why we have defined this variable. So we are going to use here GitLab deploy token, right? And additionally, we want to make sure that we don't have any new lines or anything like that in our token. So we're going to pipe them again to another command. And this command will remove any new lines that exist here. So this any here with a backslash, this will be a space essentially. So if there are any spaces, they will be removed. Additionally, we need to set this into a new variable that we can replace. So I'm going to put here a $sign at the beginning. I'm going to put this between parentheses. And what I'm going to do here, I'm going to export. So this is a way to create an environment variable, but from a script, and the name will be deploy token, right? And equals this expression. So what we have here, this part is an expression. This will be evaluated. And whatever output comes from this, it will be stored in this deploy token. And this deploy token is exactly what we have here in our pipeline. So before we commit these changes, we only are interested in making sure that this job works well. So what I'm going to do is I'm going to simply disable all the previous jobs. I'm going to put a dot before them so that they don't run. And after that, I'm going to commit this pipeline and let's see it in action. And it seems that I'm in luck. No errors while running this job. So let's take a look at the logs to see if we have everything. And indeed, it seems here that something is missing, right? Some information has been replaced. The image is replaced here. I have the version. I have here the bucket. That's definitely working fine. Here in the auths, the registry is correct. But if I'm looking at auth information, it is missing. So let's try and debug and to understand why is this information missing there. So here's the pipeline. Let's double check if we have everything correct, if we have used the right variables. So GitLab deploy token, that should be the name of the variable that we have already defined in GitLab as a variable. So that seems to be fine. Deploy token is exactly that what we have used in the file. So we can double check again the file. We'll see here, it's exactly deploy token. So that seems to be working well. So what is going on? Let's take a look again at the pipeline to see if there are any clues why this may have failed. You know, again, here we don't see it, but let's take a look at the commands that we have executed to see if there's anything suspicious in there. So what did we do? Well, first of all, we have just started the script here. We have AWS CLI. Great. We are installing here get text. So that seems to be working. Don't see any errors up to this point. And then we're exporting this variable, right? We're running this command, this expression. And then if we're looking here at line 77, we're seeing here td command not found. So apparently this expression that we have placed here gets evaluated into this variable. But when it fails, it doesn't fail the job. I'm going to open up here the pipeline and let's take a look at the deploy to production. So this is the td command that we have used. It should actually be tr, which stands for translate. Now this was just a silly mistake, but it just goes to show how important it is to actually read the logs to understand what's going on. Now we have both files All the variables have been replaced, including this time in the auth file. And we can also jump into S3 and take a look at this bucket here. We'll be able to see here the Docker run file and the auth file. They are now inside S3. The Docker run essentially contains information about what are we trying to deploy, links and mentions this auth file, which contains authentication information about how to connect to our private registry. Now let's continue with the actual deployment. So we have copied here the docker run.aws.json and the auth.json file, and they are in this S3 bucket. And now we can initialize the deployment. And the deployment happens with the AWS CLI, but this time we'll use a different service. So the service to which we're trying to deploy is Elastic Beanstalk. So I'm going to use AWS Elastic Beanstalk. And this is something that is done in 2 steps. First of all, we have to create an application version. So the command that I'm going to use here is create application version with dashes. The next command that we need to run is update environment. So I'm going to copy this and I'm going to write here update environment. So why are these 2 steps necessary? In the first step, we are taking this Docker run file and we are creating a new application version. And then once this application version has been created, we actually tell Elastic Beanstalk which environment we want to update. On Elastic Beanstalk, we have the application, but there can be multiple environments. In our case, we have a single environment, but theoretically, it's possible to take one version, to create it once, and to take it through different environments. But in this case, we only have one environment. So maybe this is why it may look a bit weird in the beginning, but these are the steps that are required in order to get this to run. Now, just saying create application version and update environment is not actually sufficient in order to get this to run. We need to specify some additional parameters. And the first parameter is we need to identify the application, right? So this is done by writing here -- application -name. And if we're looking here inside Elastic Beanstalk, you will see here, this is the application name. So I'm going to copy this as it is here. And of course, I have the possibility of putting it here directly, like application name, like this. But I don't want to do that. I want to take advantage of variables. There are multiple places where we can store this, but I'm just going to put them here inside the job itself. So we can add here a variables block. And for example, I'm going to call this app_name, column, and then this will be the value, my website. So whenever I need to use this, I'm going to put it here. So application name, $, and I'm going to reference the variable. Now there's something you need to pay attention here. Because my website is composed of 2 strings, so there's this space here in between. If we put this like this variable gets replaced, it will look like this. So this command will think that my application name is my, and then that website is some other command that we're executing or some other parameter that we're giving here. And this is not something that is recognized. So in order to get around this, we need to put this between quotes. So we'll have this string between quotes because this way it will know, okay, it is my and website. It contains also the space and the word after this. So again, I'm going to also put the variable here between quotes. And this application name is also needed for the update environment command. So I'm going to copy that there as well. Additionally, when we're creating the application version, we need to specify like a label or which version we are deploying. We already have an application version here, so it does make sense to use that. So I'm going to go ahead and write here --version -label. Don't worry if this goes on a new line. It's just the way it's edited, but actually the command is on a single line. And I'm going to use here app version. And this here for update environment, yes, it does also make sense to specify the application version. And I'm going to add the same command here, the same parameter version label to this command. Now, also when we're creating this, we need to specify somehow this file, right? So Elastic Beanstalk will not know in which bucket is this file. How can I read it and everything? So for that reason, we also have to specify that. And we're going to use this additional parameter, source-bundle. And this will allow us to specify an S3 bucket. And the S3 bucket will equal this time the bucket that we have used. So it's this one here. And we also have to specify the name of the object that we're referencing, and this is S3 key. You need to pay attention how you write this. It needs to be exactly as I have written it here. But I also noticed people in the beginning, they don't understand when they are specifying these additional parameters. Here is not, for example, it's not equal. Application name equals app name. It's just a space and then comes the value. Here, this is a bit different because this entire thing, this entire configuration here is a value that will be read later on. So for that reason here, it's okay to have these equals, but otherwise there are no equals in these commands. All right. So to create the application version, we have specified the application name. We have specified the version label. And additionally, we have specified this source bundle. So essentially, where is the file that tells us what we should deploy? This is almost the same as when we have uploaded that file manually, but with that, we have also triggered the deployment automatically. So we have done 2 steps in 1 step. Here we're doing it in 2 separate steps. So then the next part is, after creating this version, is to update the environment. So we have here the application name, we have here the version. For which application are we deploying this? Which version are we deploying? The next step would be to also specify which environment are we updating. I'm going to write here environment-name. And we also need another variable for the environment. I'm going to call it here app env name. You're free to name them as you wish. And again, I'm going to go here to Elastic Beanstalk and I'm going to copy this. I just want to make sure that I have everything exactly as it is in Elastic Beanstalk. If I specify something else, then it's not the same. So the environment name will be here. And as you can notice here, this doesn't have any spaces, so we don't need to put this value between quotes. And also, all the other values that we had here, there are no spaces, so we don't need to put any quotes there. But if any of these parameters would have a space, that value would need to be between quotes. Finally, let's also go ahead and re-enable these jobs because we will still need a Docker image now. So we will run the entire pipeline and check if our deployment is working properly. However, when we take a look at the pipeline, we'll see that the deploy to production job has failed. So let's jump into the logs, try to understand what has happened and why this job failed. You can see here the commands that we have executed. So copying these files to S3 still works, so no problems there. And the last command that was executed is this one. So Elastic Beanstalk create application version. So there's a good chance that this command is responsible for whatever error we're getting here. And then we need to look into the logs and see what is the error. And you can see here it says something access denied. Essentially it's telling that our user, which is the GitLab user that we have created, if you remember, we have created this user with programmatic access, is not authorized to perform some action, so create application version. If you remember, we have selected that the user is allowed to work with S3 resources, right? So uploading files, deleting files, things like that with S3, that works. But we haven't authorized our user to work with Elastic Beanstalk. So we need to change that. So from the AWS console, let's go ahead and open the IAM service for identity management. We'll open up our user. See here, this is the username, GitLab. And what we can do here is essentially to attach additional policies. So we have here this Amazon S3 full access. So that works. But now we want to add an additional policy. So we're going to click here on add permissions and going to attach existing policies. So I'm going to search here for Elastic Beanstalk. And I'm going to give here administrator access for AWS Elastic Beanstalk. Now, I'm not going to go into these policies in very detail. We're just interested in getting this to run. But of course, if you would use something like this in production, you would need to be very careful about what each user is allowed to do. So just keep that in mind. Just using these very generous policies in production is typically not a good idea. So I'm going to add these permissions then. And now we'll see that our user now has this additional permission here. So we can now work with Elastic Beanstalk. So going back here to the logs, instead of rerunning the entire pipeline, we can just go to this job and hit this retry button. And it will retry the same job. We haven't changed any files. And dynamically, this policy should now be applied to the user. And hopefully this job will work. So let's take a look to see what the job is doing. And now this time it looks much better. So we have no errors. And let's take a look at the first command, create application version. We have executed this and we're getting back a response, right? So it's going to tell us again, like the application name, which version we have, which bucket we're using, which is the name of the file, and so on. It also starting to process this. And the next thing, what we're getting is the update environment. So that worked without any issues. It's going to tell us again, what is the environment name. So we can take a look at that, application name, the version, and also some technical details about this. So we can take a look back into the AWS console and I'm going to look here into the Elastic Beanstalk service to see what's going on. And we'll be able to see here running versions is 60. We can click here on the environment just to make sure that we indeed have everything. The health is okay. So we can also go ahead and click on this URL and this will open up our website. So it does seem to work very well. So now we have manually tested that the deployment has been successful. But how about that we check in our pipeline that the deployment has been successful? And we can use the exact same approach that we have used so far. So I'm going to jump back into the pipeline. And here inside the deploy to production job, essentially what we want to do is to use this curl command. So it should be pretty similar to what we have here when we're testing the Docker image. I'm going to add it here to a new line. Of course, we also need to get the address itself of the application, of the environment. And if you remember, we had something for that already. We just need to update the URL for the application. So I'm going to simply copy this URL here. And from GitLab, I'm going to go to deployments, environments. And for the production environment, I'm going to go ahead and change some settings. And we're no longer using the S3 URL. We're using this one. And remove here the /. So this will be my external URL for this environment. And what we want to use here is, of course, the variable that will get us this environment. And from the predefined variables, probably remember we have used this in the past, CI environment name, slug, URL. We actually want the URL. So I'm going to copy this, get here into the pipeline configuration. And instead of website, I'm going to also replace HTTP because I don't need that anymore. So I can use CI environment URL / version. And then we're getting that version from there. Now I'm going to tell you, if we leave this command as it is right now, this will not work. And the reason for that is when we are updating this environment, AWS needs just a few seconds to actually do this deployment, to put the new version on the environment. This is not instant. But the next command will run immediately after we have essentially triggered this update. And that environment may not be ready or may still have the older version. So for that reason, this curl here will fail. So we'll not get this response. The deployment cannot be verified at this point that it has been successful or not. So what we need to do here is to wait a bit. So what we can do is, of course, to use something like sleep and to wait for like 10 seconds or something like that. But in AWS, there's a better way to do that. When we're using the AWS CLI, we have a tool which is called wait. So wait is an option. It is for various services that are at AWS, including for Elastic Beanstalk. So we can write here Elastic Beanstalk wait. And then what are we waiting for? We are waiting for this environment to be updated. So I'm going to write here environment-updated. And then we need to specify the application name, the environment name, and the version label, right? So essentially everything that we had here on the previous command, I'm going to simply copy and I'm going to add it here to the new line. And this command will do the following. It will essentially in the background, it will check with AWS, hey, are you done updating that environment? No, not yet, I need some time. Okay, wait a bit. And then we'll try again. Hey, are you done updating that environment? Okay, I'm done, good. And then we can stop waiting, and then the next command, the curl command can run, and then we can check if indeed the correct version has been deployed and if our environment is working properly. So I'm gonna go ahead and commit these changes, and we'll let the entire pipeline run and see how this goes. And the pipeline is still successful, so we can take a look into the deploy to production job and see what exactly happened here. And you'll be able to see here that this command is executed. And after this, the next command with curl is also executed, and it passes without any issues. You will see here version 61 has been deployed. This is exactly also the version label that we have here defined. So this again confirms that the version that we wanted to deploy has actually landed on the environment where we wanted to have it. So that's about it in terms of deploying to Elastic Beanstalk. So just to recap, we have gone through all the stages, and we have started by initially building our code, whatever we have here, compiling it, building it, running some tests, and then publishing this as artifacts. Then we have created a Docker image. Essentially, we have created an application. We have tested that application. And then, of course, we have really a simple pipeline here. We didn't went through any other stages. We deployed directly to production. But the principles that I've shown you here can be used for similar projects. And of course, based on all the other information that I've shown you throughout the course, you can build pipelines that are more complex than this one. But the most important thing is to understand how you can build such pipelines, how you can deploy them, and how you can end up with something that works, and generally to make this process as enjoyable as possible. Since now we are coming towards the end of the course, I thought it would be a good idea for a final assignment. And what I have here is a project which will document who has completed this course. So what you have to do is to check the course notes, and in the course notes you will find the link to this repository. You can go ahead and click here on request access. And in a few hours probably you'll receive access to this repository, and you will be able to make changes to it. So you can open the web IDE and open a merge request, and you will have to add, if you wish, of course, your name to a list of people who have completed this course. So let me show you how to do this. So once you have access to this, you will no longer see this part with requesting access, and you can open the web IDE, and you will be not asked to fork this project. That's the main difference. And then you can go ahead and change the files. The files that we want to change are located here in source. And the file that contains the code is this app.js. And here there will be a table, and I invite you to add your name and other information to this table. So for example, I've added here my name, I've added here my username for GitLab, but also my country of origin, and also a message to the entire world. And I'm going to submit this as a merge request, and I invite you to do the same. So I'm going to go ahead here, commit this, and I cannot commit directly into the main branch, so I have to go through the path of creating a merge request. So I'm creating a feature branch with my name. Let's give it a meaningful title. And then I can just go ahead and create the merge request. Once you have access to this project, you will be able to see any other merge requests. And I invite you to take a look at them to see what other people have changed to make sure that everything is working properly. And if someone breaks the pipeline in their own branch, maybe you can give people some tips in regards to what they did wrong and what didn't work so well. Essentially, be part of this review process. Try to understand how to collaborate on this project. And of course, once your merge request gets reviewed, it will be merged into the main branch, and then you will be able to see your name appearing on a web page. So I think that's kind of a nice and an interactive way of essentially concluding this course almost. And so yeah, I hope you will do this along. In terms of editing, let me give you an advice. Once there are a few people that have been added to this list here, what I highly recommend is that you don't just add your name at the end, because that's the highest chance that you will run into conflicts. So when you're trying to make changes, try to put your name somewhere in the middle or something like that between others. Try to keep the indentation and everything so that it looks nice. But yeah, that's my advice to you. So see you even after this course. I'm going to collaborate more inside the merge request. Try to play more with GitLab, with pipelines, see how it works. And yeah, looking forward to your contributions. All right, you did it. This is the end of the course, but don't go away yet. I still have some valuable tips for you. First of all, I want to give you a final reminder to terminate any AWS services you have created so that you don't encounter any unexpected costs. We have accomplished so many things in a very short amount of time. I know this was a lot to take in, but I hope it was useful and that this has opened your appetite for learning more about DevOps, GitLab, and AWS. If you enjoy this content, you could support me in creating more courses like this one by going to my YouTube channel and subscribing, link in the video description. Thank you very, very much. But there's also so much more to learn. If you found it hard to work with CLI commands, I do recommend learning about Unix utility commands and Bash. There are also other GitLab features worth exploring. If you liked working when deploying Docker containers, you may also want to learn about Kubernetes. For all the topics mentioned above and anything else I forgot to mention, you will find links in the course notes. If you enjoy my teaching style and you want to take a more advanced GitLab course, go to vdespa.com and check out the courses that I'm offering. If you are unsure which course is right for you, just send me a message on social media. I'm more than happy to help. I hope you enjoy spending time with me, and I will see you next time.